Well, hello Internet, and welcome to my full course on Postgres. In this one video, you're basically going to get a 1,000-page book crammed into one video. In the description underneath the video, there is a table of contents where you can jump around and learn everything you want. There's loads of examples in this video, and also there's a link to a transcript as well as all the code used here, and I have a lot to do, so let's get into it. All right, so the installation is actually covered at the end of the video, so you can jump to the table of contents if you want to see that first. But the big question is, why use Postgres? Well, Postgres is an object relational database that is just as fast as MySQL. However, it adheres more closely to SQL standards, and it excels at concurrency. Postgres is also superior at avoiding data corruption. And Postgres also, on top of that, provides more advanced data types and allows for the creation of even custom data types, operators, index types, and so forth. And Postgres is normally the best option when extensibility, scalability, and data integrity are the most important to you. Now, just as a general overview, a database is data that is structured into rows and columns, kind of like a spreadsheet. And to receive or change data in a database, you send commands that are called queries. And the database in turn returns a result based on that request. Databases contain many tables of data organized into rows and columns, like I said. And each column is going to represent one type of data that the database stores. Each row is going to then contain multiple pieces of data specific to each entity you are describing. So for example, we store information here, as you can see in this slide, in regards to students. And each individual value is going to be stored in what is called a cell. And then you're going to have primary keys, and they are used to define unique entities in your table. As you can see here, the one or the column labeled ID provides a unique value associated with each student. Now, we are going to be working with our database using pgadmin, and everything is exactly the same on Windows, Mac, and Linux. There's actually only one difference between the Windows and Linux versions and the Mac versions, and that is that the Linux and Mac versions are going to have an extra database called users. That's it. Everything else is the same. So whenever you first open up pgadmin, you're going to type in some type of password, and my password is turtledove. Never use that because I use that in all my tutorials. Okay, and you just log in here. Then you're going to go over to servers. Now, the very first thing we're going to want to do here is we are going to want to create a new database. So just go into databases. Actually, before I do that, I'm going to show you how to change the theme. So you're just going to go into, actually, let's go into runtime, and I'm going to zoom in and increase the fonts everywhere. So we can just go like this and zoom in here, or you can just hold down your control and zoom in like that also. So it's a little bit bigger and easier to read. And I know that everybody prefers a dark theme, so you just click on File Preferences, go down to Themes, and you can click on Dark, and save, and refresh, and reload. And there you go. Now you have that. And then if we decide, well, it went and changed, let's go and zoom in here so you can see this better. Okay, so we're going to go over to servers, and we're going to go to databases, and we're going to right click on this. We're going to say create database, and we're going to create a new one. And let's call this sales DB2. And owner Postgres, you don't need to do anything else here with this, and you can just click on save. All right, and that is going to give you a brand new database that we're going to be able to work with. And down inside of schemas over here, you're going to see all the functions we're going to be creating. We're going to be creating tons of functions and tables and all that, but we haven't created anything yet. Now, if you want to go and open up the query tool, which of course you're going to want to, you're going to want to go to your database and right-click on it and come down here to query tool and click on that. And there it opens. And this is where you're going to put your queries in, and this is, of course, where you're going to get the output from your queries. Now, of course, whenever you are going to start creating a database, which we're going to create a really large database that's going to track orders for a company, you want to think about things like and you want to make sure that one table is going to represent one real world object or one real world group. So for example, customers, orders, sales items, sales orders, all those different things are all going to have their own separate tables. Columns are then going to store one piece of information, like a name, an address, a state. Then you have to start thinking to yourself, how do different tables relate? Well, of course, if we have a sales order, we're going to need to relate our customer table over to our sales order table, and maybe a salesperson table over also to that sales order table. And this will make more sense as we create our databases. And the real goal here in designing a database is to reduce the use of redundant data. Now, one way to go and create a database is to use a real-world example. So on the left side of the screen here, you can see an invoice, which is going to represent our shoe store, which is what we're going to base our entire database on. And you can look at it and you can see what things do we have here that we would like to put inside of our table. Well, let's first off look at customer, and that would be under our bill to. So we have such things as name, so we have first name, last name, and we have email, so we have that inside of there. Company, street, you can see we're just basically placing in all the individual different things that we would like to track. And then once again, where you see ID, serial, primary key, this is going to represent the unique identification number for said customer. And I'm just going to jump over now and create this, and then I'll explain what all of these different data types mean. Like variable character, this means this is going to be a string of characters that is going to be up to 30 characters in length, and so forth and so on. But we'll get into that as we build our database. So we're just going to go in here to our query tool, and I'm going to say create, and let's zoom in here even more so make sure you can see this. Okay, so I'm going to say create table, and we'll start off just by creating our customer table, and then we have to just go and place in all the things we want. So we want to track the first name, variable number of characters. Remember, this is just a string like in other languages. Not null means that if they decide they want to create a new customer, we are not going to allow them to leave this piece of data empty. They have to give us a first name. They also have to give us a last name. So we're going to say variable number of characters, and then we're going to say 30 again, not null. And I'll get into the more specifics of the data type after I create this. We also said we want to email. So, and you just want to estimate the maximum length of an email that you may get. So I'm going to say it's 60 just to put something inside of here. Company. And again, I'm going to have this also be a string. Make sure you spell everything right. Otherwise, that will cause all kinds of problems. So we'll say variable number of characters, and let's make this 60 as well. And then we have our street, and again, variable number of characters. You're going to use variable number of characters a lot whenever you're working with databases, and not null. And then we also want our city, and we're basically just copying everything that we had from our little order sheet. So it's very, very simple. And do not put commas like that. Yeah, get rid of that. Got ahead of myself a little bit. Not null. Then put a comma. And get rid of this one also. Okay. And we're going to basically make everything a required field just to keep everything very simple. And state, this is based in the United States, so this is what I'm going to be working with. This time I'm going to use a character because I only am ever going to have 2 characters for my state. And then we can have a zip code. And there are very specific data types used by Postgres that you will get well acquainted with. And I'm going to use basically the maximum size that I need and no more than that. Phone number, this is going to be variable number of characters and 20. And again, not null, that means required. And then I'm going to have, maybe you want to offer a special to the customer on a birth date. Well, there is a date data type also. And let's go and just put null inside of there for that value, because maybe we don't, get that. I'm going to have our sex of our character, which is going to be one individual character. And I'm going to say that that's going to be not null. And then what else do we want? Well, date entered. Maybe we want to go and get the timestamp for whenever this customer became a customer. So we would know how long they've been with us and maybe an anniversary date or something along those lines. And then you're going to have serial. And we're going to have this marked as a primary key, a unique identification number. And serial, just briefly, is going to be serial, like that, is going to be an auto-incrementing number. So an integer that's auto-incrementing. And that just means that every time you add a new customer, it's automatically going to handle that for you. And after we go and create our table, we can just come up here and click on execute. And if it says created table, everything looks good here. Then you can come down inside of here, but you're not going to, well, sometimes you see it, sometimes you don't. So let's move this over here. It does have our customer table inside of there. If it ever doesn't, you ever look for something and it's not there, just right click here and click on refresh, and then you will see it. But you can see there is our customer table, and we can right click on it and click on properties, and it's going to show us some information about it. And you can directly change the table inside of here. So here is the column. So if you decide you want to change any of these or get rid of that nullability or make something a primary key or a default value, you can do that directly inside of this tool, which is very useful. And we'll get more into all of these other specific things here as we continue. But for now, we're not going to do anything, and we're going to say, yes, we're happy with our table. We do not want to update anything. Now what I want to do is go over a lot of these different data types because they can be slightly confusing. All right, so first off, you're going to have your character types. And up here you can see that what I'm basically saying is I want to store a maximum number of 5 characters. You can also just create a variable number of characters. This is a data type, and this is going to store any length of characters. You can also, like I did previously, define what I consider to be my maximum number of characters. And then you're going to also have the text data type, which is also going to store any length of characters. In regards to the numeric types, there are many. You have serial, and these are basically whole numbers that auto-increment. Like I said before, every time you add a new customer, it automatically, if you have one customer, you add another one, now all of a sudden the ID, if it's marked serial, is automatically going to become 2 and 3 and 4 and always. You're always going to use these for your identifications with your primary keys, and there are different types of serial. Mainly you're going to use just the regular serial data type, but there's also a small serial, and you can see the ranges of values. This is the minimum, this is the maximum, and these are unsigned integers. Other data types, you also have your integer data types, and these are whole numbers only, so you're not going to have any fractions of these, but these are signed, and you can see the minimums as well as the maximums for all of these different data types as well. Then you have floats. These are numbers with decimals. Here, for data types, you're going to have decimals, and you can see here how many digits you are going to be able to hold inside of them, and then how many values after the decimal. And this is the data type, decimal. Then you're going to have another one, which is numeric. Then you can get real values. You can have double precision, and you can see here the number of places of precision after the decimal place for all of those. And then you could also just simply use float, which is exactly the same as our double up here. You're also going to have Boolean data types. They're either going to have true, false, or null values, sort of, because true can also be represented with 1, a T, a Y, the word yes or on, and false can also be represented with 0, F, and no, and off. But I highly recommend that you use true and false because that will save you a lot of headaches in the future. And of course, Boolean types can also have no value or null. You're going to have date, time data types. And here we have date, And just so you understand, and no matter how you enter your date, it is automatically going to be translated into the year first, then the month, and then the day. So this is the way it's going to be stored. So it's going to be stored maybe differently than you previously entered it. Then you're going to have times. And if you would come in here and define a time just like this with PM, and then you have your 2 colons here, time without time zone, this is going to be how it's stored. You're also going to be able to store in multiple different time zones. So this would be UTC format. And you can see how I am going and changing all of these and how you can put your different time zones inside of here. So Eastern Standard Time, Pacific Time, Universal Time, and so forth and so on. All right, and that was how we'll lay those out, but it's better to see these in the real world than to worry too much about them. We also have timestamps. They're going to have date information as well as time information, and you can see exactly how those are going to be stored. And also we're going to have intervals, and they are going to represent a duration of time. So you could have 1 day like this, and you could also come in here 1 day, 1 hour, 1 minute, and 1 second, and you could see exactly how they would be stored inside of our database. And what's cool about intervals is that you can actually add and subtract intervals from different date times to play around with those concepts. There are other different data types. You're also going to have currency, binary, JSON, range, geometric, arrays, XML, UUIDs as well. And on top of that, you can even make custom data types. All right, so now let's come in here and actually insert some information into our customer table. How you do that is you go insert into, and you list your table that you want to insert data into. So I'm going to say customer. And then you can come in and say first name and just list out all of your different columns. And I went and did that for you to save a little bit of time. You can also just go down to the next line. That's perfectly fine. But if you look at this, you're going to notice that there is one column that is missing, and that is ID. Why is that? Well, ID is auto-incrementing. So that means this first customer that we enter is going to automatically be assigned the ID of 1. And then the next one gets the next one. Then you're going to say values. And inside of here, what we can do is go and list all of the information on our customer. So let's say that his name is Christopher and his last name is Jones, and all of the additional information on Mr. Christopher Jones. Let's go down to the next line. You can just keep going like this. That's perfectly fine. Okay, so we have all of our information. You may notice here, however, I have current timestamp. Well, anytime you want to get the current timestamp, like right at the moment that you create Christopher Jones, you just type in current timestamp and it goes and gets that for you. And then you're going to end all of your queries with a semicolon. And then, of course, you can go and run it. And you can see that it was inserted over here. Now what we can do is we can come over to our customer and right-click on this. And then we can go View and Edit Data. And we'll say All Rows. And it will automatically come in here, create the query. It actually creates the query for us. And it is going to display that query information down here in our table area. All right, so cool stuff. And we'll get more into select, believe me. But this is basically anytime you want to go and get information from a table, you say select, the star represents anything, customer represents the customer table, and then order by says that we want to order by whatever the ID is, so the unique identification, and this is going to be in ascending order. You could also do descending order, but that doesn't really matter in this circumstance because we only have one customer at this moment. All right, so we're done with this. So we can just come over here. You can see the little X and close that out. And now we're back inside of here. Now I said we can create custom data types, so let's go and create some. How you do that is you say create and type. And I'm going to say that I want sex type. And I want it to be set so that it's either M or F. And I'm going to create it as an enumerated type. Then that just means it has a set number of values. And I'm going to say that it either needs to be M or F. And that is going to be tied into our database. There it is. And we can go and run this. And you can see create type is down here, successful. And if you want to go and find it, you just come over here to types, and sex type shows directly inside of there. And we can come over here and go properties and definition, and you can see the different types that are allowed. And you can also go and, let's say you decide to add some more, you can do that all that you want. All right, let's close that. Well, now that you went and created your new sex type and you want to assign it to our customer table, how do you do that? So you got our customer over here, and we have our columns. So let's open up customer just to look at it, just to make sure. All right, so we have all of our columns, but we have our sex type down here, and it is listed as a single character. We do not want it to be a single character. And you can go inside of here and change to whatever different type that you would want, but let's just go and use queries instead because I prefer using queries. That's fine, get rid of that. Okay, so how we go and alter that table is we say alter table and customer, the table that we want to alter. And then you're going to say alter column, and we're going to say sex, which is the name of our column down here. And then we're going to say type, and let me make this uppercase. Doesn't matter if they're uppercase or not. And I'm going to say that I want it to be sex type now. And then I'm going to say specifically using sex, : sex type. Oops, and make sure you spell everything perfectly. All right, so got that set and run it. Query returned successful. Okay, good. I'm then also going to want to track our sales people because it's going to be important to be able to, know who sold everything. And basically what I'm going to do is I'm going to use almost exactly the same fields, except I'm going to use date hired instead of date entered here. And I'm going to use a create table just like I did before. So just in the interest of time, here is our create table for our salesperson. You can see, again, first name, variable number of characters, not null. You can see here is something different, default. If you ever want a default value placed inside of here, if none are provided, you just say default and whatever you want placed in there by default. You can also see everything else is exactly the same. So there's really nothing to explain here. And another thing you can do is sometimes whenever you're issuing queries, you might have multiple queries on your screen at one time, and you only want to execute that one query. You can just highlight it and hit this right here, and you can see the table was created. And let's come in here, and is it showing? No, it is not. So let's come up here, and let's go to this guy right here and refresh. And now you're going to see here is our customer, and then let's get rid of all that. And here is our salesperson and all of their information specific to them. Now thinking about tables once again. Now what we're doing is basically looking at a description of a product, which will be a shoe in this specific situation. And by looking at this information about the individual products, we define, is this specific shoe going to be a business shoe, or is it going to be a casual shoe or an athletic shoe? And whenever we see things like that, and that is normally a good idea that we should separate this logic, the business, athletic, or casual, out into a separate table. We can also see here information like our brand and the individual shoe name. So a brand is Allen Edmonds. The individual shoe name is Grandview. We see information like we have size. We see that we have a specific color, a price, potentially a discount, a potential weird tax rate. And then we're also going to want to chart the quantity of those numbers of shoes. Now, whenever we go in here and we decide that we want to pull this part out, we would, of course, have to create another table. And in this situation, I'm going to call this product type. And it's just simply going to have a variable number of characters, which is going to have business, casual, or athletic. And then it's going to have an ID assigned to it. So let's go over and create that table. Let's just come back inside of here and let's create a table, and let's leave this here and let's change this to product type. So product type like this. And then what are we going to have inside of it? Well, we said we're going to have a name, and it's either going to be business, athletic, or casual. And variable number of characters, 30 looks like that'll work, not null. And then let's come down here, get rid of all that stuff. It's also going to have a primary key. And guess what? Pretty much everything was done for us. So let's run that. And we have another table that was created. And of course, we're going to want to come up here and refresh this just to verify that everything is as we expect. So there's refresh. I'm looking over a microphone. That's why I'm moving around a little bit weird. And this is down in schemas. Again, let's open up schemas and tables. And now you can see here is our product type. And if we go into properties, you can see columns, and there is our information. So that's good stuff. We don't need to do that because we didn't change anything. All right, good. All right, so now we have our product type, but we actually want our product as well. Well, how are we going to define exactly what type of information we want? We're going to look at our invoice again. So if we look at our information specific to our products, we can see here that we have Brooks, which is going to represent the supplier. Then we have glycerin, which is going to represent the shoe's specific name, or glycerin 17 in this circumstance. We're going to have quantity, so we're going to want to put a quantity inside of that as well. However, I am probably also going to separate out the quantity and the things that make the shoe specific. So this is very generic. We're going to have a type ID, which is going to be athletic, business, or casual. We're going to have a name, which is going to be glycerin 17. We're going to have a supplier, which is going to be Brooks. Then we're going to have a description of the shoe. So those are going to be things, whenever you're creating tables, you want to have your tables be things that will not change. So you want to be as specific as possible, but not too specific. So what I'm going to do is I'm going to have this information on the shoe, the description, and the name. And then what I'm going to do is I'm going to create another table that is going to have things like quantity, color, size, and also price, and also all these other different things, which are going to be more specific to that type of shoe. So let's go and create those guys as well. Before we move on, I actually noticed there's something completely different here I didn't cover. Okay, so this is actually a reference to the ID down here for the product type table. Now, whenever we are using IDs from other tables, these are their primary keys down here, but up here they are actually referred to as a foreign key. And a foreign key is used to identify one of a group of possible rows in another table. So if we create a product table and we want to store a value from the product table, we can reference that information using a foreign key. And whenever we create a foreign key, it is going to have an integer type, not a serial type. And we can't use serial because Postgres will automatically assign a value for a serial type. It's not what we want. So make sure that you have this marked as integer references and then product type ID if you're referencing an ID in the product type table. So now let's go and actually create this product table. And here you can see it. So here is our product. That's the name of our table. Type ID. This is the foreign key that is going to reference our product type table ID. It's going to have a name. It's going to have a supplier, a description. You can see here we're using the text data type. And once again, for the ID, you're always going to be using serial for that. And we can come in here and we can also create that. Now, what we're doing here with this specific table is this is just going to describe what we call the quality of an item. Now, if I were to list quantity here, it would make it hard to look at this as a single item. And quantity should be kept in a completely different table. And of course, we're going to create that as well. And anything that gets in the way of being able to model an individual object should almost always be put into another separate table. So let's go and actually create that as well. So there's some things here I need to leave. So we're going to have our item specific information. So I'm going to call this item. And then we're going to have a product ID. So we're going to put it like this, and product ID, integer references, and this is going to reference a product ID in this circumstance. This is how we're tying the product table to the item table. And what specific things are we going to have inside of here? Well, we're going to have a primary key, so let's go and get rid of all this. And then from referencing our order table, what do we have inside of here? Well, we are going to have our quantity, a size, a price, maybe a picture, And then I'm probably going to separate all of the discounts and taxes outside of here. Let's just go and plug all this in here so you don't have to watch me type it out. So here we have a foreign key that references the product table. We're going to have a size, which is going to be an integer, not null for every single thing here. We're going to have color, we're going to have picture, we're going to have price, and we're also going to have our ID, of course. Of course, we'll go and run this, and we've created that table. And of course, we can come up here and verify that this was created by right-clicking on this and refreshing. And then come down inside of tables, and we can see all of our tables, and here is our item table also. This brings us to our next table. So we're also going to want to have a sales order table. And if we look at the information that we have here, what do we have? Well, we have a customer information. So we already have that stored in a separate table, which is good. So we're just going to have a foreign key referencing that customer table. We're also going to have information on the salesperson that actually sold it. So we're going to have a reference to the sales table that is created. We may want to also have a timestamp for the time the order was taken. You can see here, time and date. There's a purchase order, so of course that's going to be in the table. We're going to have credit card information, so we'll get the credit card number, as well as the expiration month, the expiration day. Maybe there's a secret code, and also the potentially different name that is on the card. And then, of course, we'll have an ID so that we can reference all the information on our sales orders. So once again, we're going to come in here and we're going to create this table. And you can see it's called sales order. It has a customer ID, foreign key, salesperson ID. It also has time order taken, purchase order, credit card number, credit card expiration month, day. You can also see that I'm using the smallest data type possible for all of these, and name on the card, and so forth and so on. And we can run that as well. And you can also see that we were able to create that table. Now there's one thing that's missing, and that one thing is going to be our potential discounts and our tax rates, as well as our quantity and also the price for all of those items. So of course we're going to create another table, and it's going to be called sales item. It's going to have a reference to our item foreign key. It's going to have a reference to our sales order ID, and then it's just going to list in all of the other different information that we need. And there is all that information as well. So we're going to create a table called sales item. It's going to have an item ID, foreign key, sales order ID, also a foreign key, and then it's just going to have the specifics on that specific transaction. And we'll run that, and we also created that table. Now, it's very important to understand how all of these tables are going to be interrelated. And what you can see here are how the different foreign keys are going to allow us to merge our data. Whenever we start issuing queries, it will become really clear how to use these different keys. But basically, the product type is going to be linked to the product. So here is how those link. That ID goes right here. The product is going to be linked to the item, which is a more specific version of our product. And then both the item and the sales order are going to be linked to the sales item table. And there are going to be many different foreign keys linking tables, but I think that in general, this is enough to cover at this moment. Now I'm going to show you a whole bunch of different queries for doing all kinds of things. Let's say you would want to add a new column. So all you do is you say alter and the table that you want to add a column to. And I'm going to go and say that I want sales, the sales item table is what I want to be working with. And I want to add a new column, and it's going to be called day of week. And it is going to have a variable number of characters. Let's say it is 8 because that makes sense. And there you go. So that's going to allow you to add a day of the week column to our sales item table. So let's go and run that. And we were able to alter that. And this is going to be sales item. So let's come up here and let's refresh this. Refresh and sales item. And we're specifically targeting the sales item table. So let's look at the properties and let's look at the columns. And day of week is in here, and you can see that there is our information exactly as we entered it. Okay, so let's close that. Let's say that you would like to modify a column or change it in any way. Well, you're going to be using alter table again. Let's stick with sales item, makes sense, and let's get rid of the rest of this. All right, so there that is. And we want to set it to not null, for example. So you just reference the table. You then say alter and column. And all of this is on GitHub. We're going to be using day of week again. And I'm going to set it for not null. Right like that. And we can run this and it will come up here. You can see that it's successful. All right. Then we decide that we want to change the name of a column. So how do we do that? We're going to use sales or alter table again with our sales item, except we'll just get rid of this. And we're going to say rename column. And we'll say day of week. Maybe somebody says we don't like that. And we want to change it to something that is shorter, that makes more sense. So we're going to say weekday. There that is, and run it. And you can see we did that as well. And then also you may want to drop a column altogether. You might be like, why did I even do all that? Well, we're going to say alter table, sales item, and we're just going to change this to drop column and day, or this is now weekday. Remember, we changed that. So let's get rid of that and let's run that. And that is now gone. So if we go into our sales item table and property and columns, then you can see that weekday doesn't even exist. So that is how we go and do all that stuff. Let's get rid of that. Okay, so let's go and say we want to add another table to this. So this is going to represent our transaction type. So we'll say create table and transaction type. And then after that, come down here, we'll say name, variable number of characters is going to be 30, and let's make this not null, and payment type. So that looks like something we might want. So character, and we'll put this as 30 as well, and not null as well. And then of course, what did I forget? I didn't forget it, I just didn't type it yet. Okay, so serial, whoops, serial, like that. And this is going to be our primary key. And there we are. We just created a brand new table. I'm in the habit of highlighting things, but in this circumstance, because there's only one query, I don't need to. Now let's say we would like to rename that table. Well, guess what? We're going to use alter table again. And what's it called? It's called transaction type. And we want to rename it to just simply transaction. Well, there that is, and let's run that, and it's successful. So that's how we can do that. Let's say that we would like to create an index based on a individual single column. Well, we'll just come in and we're going to do, let's get rid of this. We'll say create index transaction ID on transaction, the name of our table, so transaction, and we want to make a unique index on our name column. We can do this and run that. Okay, that was also successful. Let's say we can also come in here and actually create an index based off of multiple different columns. So let's just create index again, and we will call this create a transaction ID 2, just to put something inside of there. And we could say on transaction, but this time we want to be based off of not only the name, but also the payment type. And these are all columns inside of here. We can run that, and now we created another one. So this is going to be, okay, good stuff. Another thing that we might want to do is we may want to delete data in a table. Well, to do that, we say truncate table and transaction, like that, and run it. Boom. And the table has been truncated. And then on top of that, that just deletes all the data inside of a table. If you want to actually get rid of a table altogether, you come in and just say drop table transaction, run that, and now it doesn't exist. And if we come over here and we refresh this, there it is, and refresh, you can see that that table name transaction doesn't even exist inside of here. But let's come in and let's go and add in some more data, because then we'll be allowed to start really doing some cool query things. So what I want to do is, for our product type table, remember I wanted the different product types to be either business, casual, or athletic. So how I can enter those in is I say insert into, and then you list whatever your table is called. It's called product type. And what am I going to insert inside of here? Name. That's it. Nothing else. And values. And I'm going to say that I want business. So business, like that. And there that is. And then I'm going to go and do this for multiple different types. So let's go like this and like this. And we will also, remember, the ID is automatically put inside of there. So we'll have this be casual. Whoops, let's keep everything consistent. Casual. And also this one right here is going to be athletic. Athletic with a lower T, like that. And we can run this, and boom. And then we can come in and check out that information. And how we can do it is say select. Star represents everything from the table called product type. Like that. And if we just highlight this and run it, you can see it's going to give us information that we just entered. So there's business. Because it was entered first, it gets the ID 1. And then we have casual and athletic on top of that. All right, so good stuff. Another thing that's interesting to know is that you can also insert multiple rows without defining the column names if you put the values in the same order as our table data. So why don't I demonstrate that? So let's come inside of here. And what I want to do now is I want to enter some of our product information. If you don't remember, that's the supplier, the individual shoe name, and a description for the shoe. So what we can do is we can say something like insert into product. So here is our table name and the values that we want to enter. All right, and then inside of here, we're going to say that, let's look at it. So what do we have here? So remember, you have to put them in exactly the same order. So we're working with a product table. So come over here and let's look at our columns. So we have the product type, which in this circumstance is going to be business. So let's say this is 1. That is the ID for business over inside of product type. And then we have our specifics. So we can say something like Grandview is the specific shoe name. So that's the name. Then we're going to have our supplier. And this is going to be Alan Edmonds. And then we're going to have a description for said shoe. And there is this really long description for our shoe. And you can see that just as long as you have the type ID, which we do, name, supplier, description, and then remember, we never put in our ID. We have all that information. We do not need to do anything else. And there that is. And what I'm going to do here is just go and paste in a whole bunch of these. And there you can see all of our different shoes that we are going to be selling. And remember, there's always a semicolon here at the end. But you can see that if we go and put this inside of here, all in the right order, and run it, that it went and successfully entered all of that information. And then we can come in and verify that it did that by just coming in and saying select everything from product, like this. And if we run that, you're going to see that we have a listing for all of our shoe names as well as our suppliers and descriptions, and it auto created all of the IDs for all of that information. Now I'd like to come in and enter in some customer information, but maybe somebody was looking at your database table and said, you know what, I'm not sure if you have the right data type for customer. So let's come in here and let's look at it. So we go and look at properties and columns, and we're looking at them, and here we have small int. Well, we think that maybe that smart person was correct. And we go back and we check our notes and we find out that yes, indeed, small int only has a maximum value of 32767. Well, if you don't know about US zip codes, this is too small. So what we're going to have to do is we're going to have to change it to an integer. Yes, this is overkill, but we're going to have to change it from small int to integer. But we know how to alter tables, and maybe for just practice, you could see if you could alter that table based off of what I taught you previously. If not, I will show you. And there's a lot to learn here, so don't worry about it if you didn't get it. We're just going to say alter table. And what table are we altering? Our customer table. And then we want to alter what? We want to alter a column. What column? We want to alter the zip column. And what do we want to do? We want to change its type to an integer. And we can do that. And we can run it. It's successful. And if we come in here to customer and properties and columns and zip, you can now see that it is an integer, not a small int. So now we need to enter in all of our customer information. And I'm not going to waste your time by having you watch me type all that in. I'm just going to plug it in. Okay, so what do we have here? Well, we have all of our customer data. We have our first name, last name, emails. We have the company they work for, the address. We have the city, state, zip, phone number, birth date, sex date entered, and all of those additional values. And instead of current timestamp, I actually put a real date inside of there. And also, remember, semicolon at the end. All right, if we enter all that information, run it, you can see it was successful. And we can verify it was successful by coming in and saying select everything from what? Customer. Like that, and run it. And boom, there is all of our customer data, all looking really good. Now what we need to do is come in here and insert our salespeople. But before we do that, what if we made the same mistake with our zip code with our salespeople? So we'll have salesperson down here. Let's go and see. So we'll go properties, columns, and zip. Yes, we used a small int again. So we were being dumb. We didn't realize what we were doing. So let's go and fix it. Well, now see, after I showed it to you multiple times, see if you can go and change the zip from a small int to an integer. Otherwise, I will show you. Alter. What are we doing? We're altering a table. What is the table's name? It is called salesperson. What are we doing? We are altering a column. And what is the column's name? Zip. What are we specifically altering? The type. And what do we want it to be? We want it to be an integer. And we can run that. And that also worked. All right, so now after we have all of that set, now we can enter in all of our salespeople data. So let's go and grab that. We don't have that many salespeople. Let's paste them inside of there. And again, it has all the relevant information for it. And remember, you don't need all of the different column names if you put it in order, but I just did that just to be descriptive. And there we are. We inserted all of it, and we can come in and we can verify that. So we'll say select everything from salesperson, and like that, whoop, everything from salesperson, and highlight this so we just execute that part, run it, and there is all of our salespeople information. Okay, so we're getting a lot of information in here that we will then start running a bazillion queries on. But what we'd like to do now is we'd like to insert some information into our items table. So where is our items table? Here it is. Let's look at what we got inside of here. Let's look at our columns. Okay, so we have our product ID. We have a size. We have a color. Picture, this is going to be a character. I am just going to have that be coming soon and put that inside of there. Normally what you would do is put a URL to, location for the image, price, and ID. All right, so let's go and put all of that information in. Whole bunch of stuff. Okay, paste it inside of here. And here we have our information. So we have into values, and this time I'm not putting in the column names. And if we just go and look at item and columns, you can see we have our product ID. We have our size, we have the color, we have coming soon where we will have our pictures, and then also our individual price. Make sure you put a semicolon at the end, and let's go and run that guy also. There it is. And now to verify that all that is in there, we can just say select what, everything, from where, and that is going to be item. And run that, and now we can see is all of our item information. So what else do we need to do? Well, we're going to need to go and put some information into our sales order table. Another thing that may have been brought to our attention is our purchase order number, specifically with our sales order. Somebody's like, I don't know if that's big enough. Well, let's look. So we got our item, and we are going to go into our sales order information, and we'll look at properties and columns. And purchase order number is set as an integer. Okay, well, how big is an integer? Let's go and close that. Here we can see, here is our integer information. And those are a lot of different orders, but we're planning on selling just more than 2.1 million shoes. We want to be selling this big of a number of shoes. So yes, before we enter our information, yeah, it's probably better to go and actually change that into a big integer also. And why don't we do it in a different way this time? So we'll go sales order, and we'll go properties like this, and columns, and it was purchase order number, right? Let's come in here and let's change it into a big int instead and say save. And it's going to automatically go and change that into big integers for us instead. So now what we want to do is we want to go and insert all of our sales order data. So here is our sales orders, and here is our columns. So we have all of this data that we're going to put inside of here, and there it is. Okay, so what do we have inside of here? Well, again, we're not going to put the column names because everything's in order. We're going to have our customer ID, our individual salesperson, the time the order was taken, the purchase order number, credit card number, and of course, these are not, real credit cards, and the name on the card and all of that other stuff. I just randomly generated all this information and plugged it inside of there. Okay, so there we go, got all that, and let's run that again. And we can see we placed all that in there. That is sales order. Let's come in here and just do select all, delete that, and we'll say select everything from, and it was sales order, and run that, and boom, here is all of our sales order information. Now, another thing, we have a lot of our tables populated. However, we do not have anything in sales item, do we? So let's go select everything from sales item, like that. Run it, and successfully run, but there is 0 rows affected. There's nothing, okay? So we're going to have to put some information in regards to our sales items. So what type of information do we have in our sales items? Let's get rid of this, and let's get rid of that. Let's go sales items. Here they are, and here is the columns. So we have an item ID, a sales order ID, and then we have specifics like quantity, discount, tax rates, sales tax rates, and then of course an ID as well. So let's go and plug all of that information in here as well. Plug it inside of there and run it. And again, that was successful. Let's go and get rid of all this. Let's do a select all, delete, and then let's go like this and select everything from, and this is sales item, right like that, and run it. And you can see here is all of that additional data. So good stuff. All right, so we populated all of our tables with data. And now it is time to start doing some really interesting things. What I'd like to do now is start talking about pulling that data in useful and interesting ways using a never-ending plethora of different query commands. All right, so here we're going to start off by just covering select. Yes, I know you saw it before, and from, and where, and order by, and limit, and then just work up from there. Now, of course, let's just do another select. This is how we're going to be able to select everything in our sales item table. And boom, and there you can see all of the different pieces of data inside of there. Now, where is going to be used to define which rows are included in a result based off of different conditions. So, for example, let's say you wanted to show all sales with a discount greater than 15 or something. All right, but first off, you're going to need to know about all. Oh, did I tell you how to use comments in pgadmin? I don't think I did. This is how you do a comment, just 2 dashes, and there is a comment. And you can also do multi-line comments by moving / and multi-line comment like this. Okay, there you go. So I got that covered. Well, you're going to have some different conditional operators you need to be aware of. So let's come down inside of here, and here they are. So you're going to have your equal sign, and less than, greater than, less than or equal to, greater than or equal to, not equal to, and also you can use this more traditional not equal to as well. So let's say that we want to come in here and we want to do exactly what I said. We want to go and find sales items where a discount is greater than 0.15 or 15%. So you could do something like select everything from, and where are we getting it? As you can tell, it doesn't matter where you put your code, it all is going to work here. So we're going to say we're going to get information from our sales item table and where, and we're going to say that we want to do discount greater than 15%. And we can run that. And you can see here it is. I just hit F5 instead of clicking up here. I just did that in the beginning of the video. I'm not going to do it anymore. So you can see there you get your different results out there on the screen. And your discount rate is going to be, I don't know if you can see this, but it's 16. Let's move it up here a little bit. 16, 19, 18, 18, and it fits the condition. So very, very important first step. Then you're going to also have what are called logical operators, and they're going to allow you to stack your different conditional statements. And they're very easy to remember. You're going to have and, you're going to have or, and you're going to have not. So in this situation, let's say that we would like to go and find all order dates for all orders in December of 2018. Well, we can do that. So we'll say select and everything from, and let's get information from sales item this time. And our condition is going to be where, well, let's just change that. Let's say we want to get everything from just when our sales item was taken. So that is time, order, taken. And we are going to get rid of this part right here. And let's say from, let's keep these on separate lines, a little bit more complicated. Sales order is where we're going to be pulling them from, that table. And let's stack some conditionals. So we'll say where time, order, taken, that is greater than, and then let's throw a date inside of here. So I'll say 2018-12-01, and time, order, taken, and this will be less than, and we'll do 2018-12-31. Okay, so that's going to give us everything in December 2018. And let's just go run that. And you can see that we have two of those that took place. And of course, we could go and put additional information. So we have our sales order. Let's go and get rid of that, get rid of that. And where is sales order? Sales order's over here. And columns. And let's say we wanted to get that, and we also wanted to get our customer ID. We could get that as well. And now you get your customer ID. So you can, of course, pull multiple different pieces of data, both from the sales order table. And I'm going to show you here soon exactly how you can go and get multiple different pieces of data from multiple different tables. Guess what? You're going to be using foreign keys to do that. Let's talk about order by now. So let's get this out of here. And let's say we want to get everything. So I'm going to say select everything. And I'm going to say from, and I'll do sales item this time. And I'm going to say where the discount is greater than 0.15. And then I want to change the order, how they are output on the screen. So I'm going to say order by, and I'm going to say that I want to order them by the discount. So let's run it. And you can see that we're able to pull that also. So we have our discount, so you can see who is getting the greatest discount. So it starts at 0.16 and goes down to, what is the biggest discount here? 19, oh, somebody got a 20% discount. Okay, so that is another way of using order by. Another thing you can do is, let's say we wanted the greatest order up here at the top instead of going from lowest to highest. We just come in here after discount and say descending instead. And now you will get exactly what you want. There is your 20% is the greatest amount of discount. Another thing is sometimes We want to limit the number of rows in our results. So let's say you wanted to just get like the top 5 or the top 10 or something along those lines. So we got order by discount descending, and then you can follow that up with limit. You can put whatever you want in here. So I just want 5 of them, and it will just give me the top 5. That's it. Now I could do the top 10 or anything after that. And you can get the results, you can get the name, the phone number, and state. Let's go and do another query here now. Let's go something like select. And let's say that we want to have the first and the last name combined into one field. We can do that with concat. So we'll say concat and first name, and then we will put a space there. And then we'll say that we want last name. And you could use an alias for this. So you could say as, and let's just refer to it just as name. And let's say that we also want to get the phone number and the state. And now we want to, from, and where we're going to be pulling this information is from customer. So customer, like that. And let's say that we want to just get this customer information for people that live in Texas or something like that. So I'll say where state is equal to and Texas, like that. And we can run it. And whoops, what'd I do? From customer. There we are. Customer. And we'll run it again. And now you can see we get just customers from the state of Texas, and that this column has been renamed as name, and also it has our people's names of first and last name all in one field. So that's very useful. Another thing you can do is you can perform calculations. So let's say, and there's tons of functions we can use here, and we're going to be touching on a lot of them over the course of this video. So let's say we want to get the total value of all business shoes that are in our inventory. So we're going to say select, and what do we need for business shoes? Well, we need our product ID, and we want to sum the price. So I'm going to go sum, and I'm going to go and get all of the prices, and I'm going to call this as, and I'm going to change the name of this column to total. And where are we going to get this from? Well, we're going to go from item, where, and let's throw where on another floor here. So we'll say where product ID 1 is actually equal to our business shoes. And let's also say that we want to group them by the product ID, which is going to then give us our sum for just the business shoes. So we'll say group by and product ID. And there we go. And this is going to give us our total value of our inventory for our business shoes. Clearly, you know, a store would have way more products than this, but I'm just trying to keep it easy to understand. Another very useful keyword or command is distinct. You can use distinct to do things like eliminate duplicates. So let's say we wanted to get a list of states we have customers in. For example, we could say something like select and distinct, and we're going to say what we want to be distinct is the state from customer, and then we'll say that we want to order by the state, and there we go. And that we have customers in California, Georgia, Illinois, New Jersey, and Texas. Let's say that we wanted to find all states where we have customers, but we do not want to include California. Well, we're going to still say select and distinct state from customer. All that's still good, but we're going to put in a where clause. We're going to say where state is not equal to California. We decide we don't like California. All right, so there it is. And now we don't have California. Of course, we can also come in here. There's the other version of not equal to, and use that instead if we would prefer. Another little tool here is in. We could also go distinct state from customer, and let's say that we just want states that are listed. So we could say state in, and we could list the people we want. So let's say we want just California. We like California again, and New Jersey. We could do that and run it, and there is California and New Jersey. Another thing, well, let's just cut to the chase here. It's going to be extremely important for us to be able to get data from multiple different tables. And we're going to be able to get results from multiple tables with either inner joins, outer joins, or unions. Now, the most common join is going to be your inner join. And with it, you join data from two tables in the from clause and with the join keyword. And the on keyword is going to be used to define the join condition. So let's say we wanted to do something like get all items ordered ever and sort them by ID while listing their price. So I'm going to say select, and I'm going to say item ID and price from and item, and I want to do an inner join with sales item. So we're joining the item and the sales item tables here. And I'm going to say how they want to be joined is they share a key. So I want the item ID to be equal to the sales item ID. And then I want to order by item ID. And there it is. And we can go and run this as well. And this is going to show all of that additional information. So here are our IDs, and here are going to be, these are going to be the items that are ordered. So that is the reason why we have some items in our inventory that were not ordered. And this is going to be the listing price for all of those different orders. So just to reiterate, we're going to use our join condition to find IDs that are equal in the tables item as well as sales item. Let's look at those. So we have sales item and columns, and then we have the item and columns. So we have here the product ID, and this was right? Yes. So we have item right here, and we are joining with our item ID. This guy right here is going to be joined with our other, which is sales item. And you can see here is the item ID. So here it is a foreign key. Here it is a primary key. And these joins, like I said, are normally done using primary and foreign keys in the tables. And whenever we join tables, while checking for equality between a common column, this is called an equijoin. So let's come in here and let's do an example. Let's do item ID and price once again from item, inner join, sales item, and we'll do on sales item, sales ID, and let's also go and stack this. So let's say we want to go and get, let's do an and on this. We'll say and, or maybe it makes more sense to put it up here. I don't like to keep these lines too long. We can stack these and say something like price is greater than 120 or something like that along those lines. And there you can see we got that additional information. Now what I'd like to do is take it up another notch, and I want to join three tables. So I'm going to get the orders and the quantity and the total sales. So just to show this in picture form, what we're going to be doing is we're going to be using the sales order. So this guy right here. So we'll have sales order, and we're also going to have our sales item. And then we're also going to join to our item. And what we specifically are going to say is that we want to go to our sales item area, and we want to get our sales order ID. And we want to make sure that it matches up with our sales order ID down here. So this guy is going to match with this guy as this arrow is displaying. And then we also want to go to item over here, and we want to make sure that this item ID down here is going to match up with our sales item ID. So sales item ID is up here. So this guy is, these two are going to be connected through this ID here, and then this ID is going to connect to this one. And then we're going to join all of them together and be able to pull out all kinds of interesting information. So what are we going to do? Let's just start from scratch. So we'll go to select like this, and I'm going to say I want my sales order table dot ID, and I also want my sales item table, and I want to get quantity like that, and I'm also going to get the item dot price, and let's go and get the quantity and multiply it by the price. So let's go in the next line. So I'm going to say sales and item. I'm referring to the sales item table and the quantity stored there, and I'm going to multiply that times item table price, and then I'm going to give that a name of total. So now we need to define how we are going to be matching up all of these different tables. So I'm going to say, well, I want the sales order, and I want to join it to the sales item table. And how I want to join them is where I have sales item equal to, that is, oh no, that's going to be, yeah, sales item dot and sales order ID is the name for this, and I want it to be equal to the sales order dot ID. And what I'm referring to here, I have all this information, the table information, in a chart, and I'm looking at it, but it looks like this. Okay, so this is how we are going to be merging. So just to reiterate, to make sure this is understandable, I want to use my sales order table, and I want to merge it with my sales item table. So what I'm saying is I want these to be matched, the sales order ID and the ID for the table sales order. And that is all that I did there. Okay, but I said I want to merge 3 tables. So what do I do? Well, I just put in a new join and what table I want to join to them. And then they just need to match up. A primary key needs to fit perfectly with a foreign key. So I'll say on item dot ID equal to, and I'll say sales item and item ID. And that's why it's good to keep your names logical as well. And then what I want to do is I want to say order by, and this is going to be the sales order dot ID. And if we are on that, boom, you can see that everything comes up. So let's just bring this up here so you can see it a little bit better. We have our IDs, we have our quantities, and we have all of our prices. And you can see in a couple situations here, there's more quantity, so that's going to be double the total amount of money that we have on those. Okay? All right, so what do I want to do now? Well, let's talk about some arithmetic operators, because I think they're kind of important, except they're going to be very easy to understand. We are going to have the ability to add, subtract, divide. You can also do integer division with div, and you're also going to be able to get the modulus, which is going to be the remainder of a division, which is going to be very important later on. Those are pretty straightforward. Okay, so what do I want to do now? Well, you can also define the join conditions using where, but this isn't necessarily considered best practice, but I'll cover it anyway, just so that you know if you ever see it. Okay, so let's go and do something like item ID and price. And we're going to be pulling that from item and sales item. And I'll say where the item dot ID is equal to sales item and item dot ID, item underscore ID, ID, there we are. Okay, and then I'll say and the price is going to be greater than $120. And I'll also say I want to order them by the item ID. And we can run it, and you can see here they are. Okay, so another way of using where, but like I said, not necessarily the greatest of ideas to do this, but it can be done. Now, another type of join is what is called an outer join. And outer joins are going to return all of the rows from one of the tables being joined, even if no matches are found. And so let's go and create them. Well, basically, let's talk about something else. Basically, a left outer join is going to return all rows from the table being joined on the left, and a right outer join is going to return all rows from the table that's on the right. And it's common practice to avoid right joins. So you're more than likely going to be using a left join if you do this at all. Let's just go and do an example so you can see what it looks like. So I'm going to say select name, and I want to get my supplier, and I also want to do price, and I'm going to say from product, and I'll do a left join with item. And then I have my condition, so I'm going to say on, and the condition's always the same. It's going to be connecting with foreign keys, and more than likely, unless you use where, which I told you, don't really want to do. So I'm going to do, this is product ID is the name of that, and then the other one is the product table with its ID. And I like to do, I always have my primary keys with the same name ID, just because it makes it very easy. I see this, I know this is the primary key, and I know that this is my foreign key. And then guess what? This product ID looks almost exactly as that, and it's very understandable. I can see exactly what's going on. And let's just say we want to do something like order by and name, and run it and pull this up. And you're going to see that we get our name, and we get our supplier, and we also get our price inside of here. And you can cycle through. See our limited number of shoes that we have available. Very sad shoe store. But, and like I said, I'm just keeping it simple. All right, so that is how we can do that type of join, or an outer left join. And let's talk about cross joins now. So let's come in, and as you're going to see, I don't use the other ones that much, but I want to cover them. Now, basically, a cross join is going to include data from each row in both tables. So let's say that I want to go and grab information from the item and the sales item table. And so we'll say select sales order ID, like that, and the quantity and the product ID. And I'm going to say from table item, and I'm going to do a cross join and with the sales item table, and I'm going to say that I want to do an order by sales order ID, and run it. And you can see here that we get our sales order IDs, our quantities, and our product IDs as well. Another way to combine tables is with what are called unions. And unions combine the results of two or more select statements into one result. Now, one thing that's important to remember is that each result must return the same number of columns, and on top of that, data in each column must have the same data type. So let's do something a little bit more interesting here. Let's say we want to send birthday cards or something to all of our customers and salespeople for the month of December. Could we do this? Yes, we could. So we'll say select, and we'll do first name and last name. And we need our location also, because how else are we going to send this information? And let's get our birth date as well. And let's go and get this from our customer table. All right, now if we want to go and just get the month out of a date data type, what we do is we say where and extract, and we're going to say month from and the birth date. And you can also get the day and year in very similar ways. And I'm going to say equal to 12 in this situation. And then I'm going to do a union between these, and you just do another select, and I'm going to say first name, last name, da 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 da. Let's just go and copy all of this. So let's copy that, and let's throw this here. Again, you're not going to use unions very much. Whenever we get into the part of the tutorial where I am really doing real world stuff, you're going to see that I don't use the unions and the outer joins and all this stuff all that much. So I'm going to say from sales person and where, and I'm going to do another one exactly the same. So let's just copy this and paste this down inside of there. And then let's say that we want to do an order by. So order by, and it's going to be ordered by the birth date, like that. And run it, and you can see that we got all of our pertinent information for our employees that were born in December. And this is employees as well as customers. I guess this is kind of a real world thing. That's something that you might want to do. Let's go and get this out of here also. Okay, so we talked about previously how null is used when a value is not known. Well, we can use isNull to search for potential problems. So, for example, null results where they should not exist. So let's say we want to search for items with null prices. We don't have any, but I'm going to just do it anyway just so you can see. And so let's do product ID and price. At least I don't believe I have any. Well, I guess we'll find out. So we'll say in our item table where the price is equal to null, like that, and run it. And you can see that we don't have anything. So we could also come in here and say price, like this, is not null, and run that. And you can see everything comes back. And total rows is 50. Another thing we got is we can work with regular expressions to search for simple string matches or really complicated string match. So let's say that we wanted to match any customer whose name begins with an M. How could we do that? Well, we could go select and first name and last name, and from our customer table where the first name is, and we could use, there's a couple different commands, and I'm going to show you all of them. So I'm going to say similar to, and if we want to match for names that begin with M, just throw an M inside of here, and then you throw the % inside of here, and that % is going to match for 0 or more characters. So basically anything afterwards. And you can see there we got our information, and all of these first names begin with the letter M. Another thing is we have a lot of different commands. Let's do first name, last name from customer, and then let's say something like we want to match for somebody who has the first name begins with A and then has 5 characters after it. There is another regular expression character underscore like this, and it's going to match for any single character. So one single character. So we said that let's try to match for, I think I have an Ashley inside of here. So I'm going to say where first name, and instead of using similar to, I'm going to use like. So I'm going to say like, everything else here is the same. Let's change this to A, and then I'm going to do 5 underscores. So 1, 2, 3, 4, 5, like that, and run it. And yes, indeed, I do have an Ashley inside of there. So that's going to match for exactly that. But if I put in another underscore inside of here, that's looking for a name that begins with A and then has 6 characters after it, obviously. Run it, you can see we get no results. And we can take that off of there, and let's see if we have any. No, we don't have anybody like. All right, so that is how we can use like. Another one, let's go and let's say we want to return all customers whose first name begins with a D or whose last name begins, let's make it even more complicated, whose last name ends with an N. So let's do first name, last name, customer, And let's do first name, and let's get rid of this part, and let's use similar again. So I'm going to say similar to, and I'm going to say that the first name is going to begin with a D, and then it's going to have how many characters, doesn't matter, just a bunch of them. Or the last name is, and I'll do similar again to, and then I said I wanted the last name. You can have that be lowercase, but okay, last name ends. So I'm going to put any number of characters in front of it, and then an N at the end of that. Run it, and we said that first name is going to begin with a D. Well, there's a Daniel, and it's going to end with an end, or end with an N. Well, you can see here, we know why that matched because it's a D. Here, there's no D, but Brown ends with an N, and that's the reason why all those matched up. Let's go and take a look at some regular expressions here and give you a very good overview of them. All right, so here's some regular expression patterns. Now, I showed you the underscore. You could also use a dot for any single character. You could use a star for 0 or more. You could use a plus for 1 or more. You could use this caret symbol here. That represents the beginning of a string. You can have the $sign represent also the end of a string. Anytime, and I'm going to demonstrate these in real-world examples, but it is good to know this because this is very, very important. Let's say that you did not want to match for the letters A and B. You just have your brackets and a caret symbol and the closing caret symbol, and it will not match for A or B. If you want to match for A and B, then you use that. You can have all uppercase letters by just putting a dash between them, and the same for lowercase as well as numbers. And then whenever you have your curly brackets here with an N inside of it, that's saying N instances of, which means, a certain number of letters, numbers, whatever you want, which are going to be represented by these or actual characters. You could also do instances of between M and N, so a maximum and a minimum. And then you can use, here's our OR symbol here. This is going to match either for the letter M or the letter N. But I'm going to show you some real world examples so that you can better understand this concept. All right, so let's say that we wanted to get the first name that starts with MA. So I'm going to do that. So I'm going to say first name and last name, fine. I'm going to be working with the customers table as well. And I'm going to say where the first name, and here I am going to use another operator. This is going to be our tilde, because you don't want to leave that out. This is going to allow us to search for regular expressions. So what did I say? I wanted to match a first name that starts with MA. So I'm going to put the caret symbol inside here, representing the beginning of the name or the beginning of the string, then followed with M and A. Don't need to put any other information inside of it, and it's going to give you Matthew, Matthew, Matthew. All right. Let's say we wanted to match names that end with EZ. So we still have our first name and our last name, customer. Let's just change this to last name though, just to be different. So last name, and here we use the caret symbol to reference the beginning of a string. Now what we want to do is represent the end of a string. So we said names that end with EZ, and then I'm going to put our $sign inside of there. Run that. And now you get all the Martinez's showing up. Let's say we wanted to match last names that end with EZ or SON. So again, from customer, where, and we could go last name and our tilde, and we can just go EZ and replace this little $sign here with our OR sign. So we'll go like this and SON and run it. And now you get Martinez or Anderson or Johnson or Wilson or Jackson and all of those different names. Now, the cool thing about regular expressions is whenever you learn them, they're pretty much exactly the same with every other programming language. So, and I have tutorials on regular expressions. So you just search for my name, regular expression, and that will show up. Let's do another one though. Let's say that we want last names that contain W, X, Y, or Z. So all of this stays exactly the same, except we go and get rid of this and inside of brackets. And what we're looking for is all the letters W through Z inside of them. Run it, and you can see there is our list. I think that's enough for now in regards to regular expressions. And now I'd like to talk about group by. Okay, so group by, we've already talked about it briefly, but I want to get into more detail now. Group by is going to define how results are grouped. Okay, pretty simple. And we're going to use another operator, count. And what it's going to do is return the total number of records that match. And then we'll use group by to return a single row for each unique value. So let's do an example here. So let's say we wanted to find out how many customers have birthdays in certain months. So we can do that. So we're going to say select, and then we're going to use extract to get the month from the birth date. And let's go and give this an alias of month. And also I want to count how many total customers have a birthday in that month. So to do that, we just say count and all of them. And let's have this have a name of amount, or an alias of amount. Where did I say I'm pulling this from? The customer table. And how do I want to group them? Well, I want to group them by the month. And I'm using the alias here is our month. And then I want to order them by the month as well, and run it. And we can see here for our customers, we have, what's the big month? Well, there's a couple of them. So we have, that would be March, we have 3, and so forth and so on. All right. So that is how we can use the group by, and we'll be doing more with group by, of course. Another cool, useful tool is halving. And what halving is going to do is it's going to narrow the results based off of a condition. So in this situation, let's say we want to get months if more than one person has a birthday that month. So we'll say select extract month from birth date as month, and we're going to count all of them. And let's say from customer, group by month, and then we're going to also come in and say having a count that is greater than 1. So we're only going to get people that have at least more than one person. And there you can see that's exactly what we got. All right, good stuff. Another thing is we have a lot of aggregate functions. We've covered them already. And basically an aggregate function is just going to return a single value from multiple different parameters. And let's do another one. I've done counts one, like I said before. Let's say we want to go and get the sum price for an item. So I'll say select and sum and price and from item, like this. And you can go and get all of the prices for every single item. You can also, there's a whole bunch of them. So let's see, what do I want to do here? Let's get a whole bunch of different things. So we'll do sum price, and we'll say something like as value. And then let's go and get a count, and let's get all of those. Oops. And let's give this an alias of items, like this. Or maybe we want to put the count first. So let's go grab that. I think that makes more sense. Throw count here. And then we'll have our sum. And let's go and let's say we wanted to do an average. So I'm going to go round. These are all aggregate functions. Average is also an aggregate function. And we'll do price. And we'll go and divide by 2 in this situation. And say as average. Let's have it be consistent as average. And let's say we want to get the minimum price. We'll do that. And we'll go as and make this minimum. And then we can also get our maximum price. So we'll do price and again, and then this will be labeled as max. And we're going to get all those from the items table. So let's run it. And there you can see. We have 50 total items, and the sum for all of them is $7,231. The average price is $144.63. The minimum value for an item is $86, and the maximum is $199. And that brings us to another concept, which is very useful, which are views. All right, so a view is extremely useful. They are basically select statements that that's result is stored in your database. And let's make a really complicated view because we haven't made anything that complicated yet. So what I want to do here is I want to create a view that contains our main purchase order information. So I'm going to say create. This is how you create a view. You say create view and purchase order overview, and that is the name for our view. And I'm going to say as, and then we're going to say select sales order and purchase order number and the customer company. Let's get that. Let's go down to the next line. Let's go to sales item quantity. Quantity. Make sure I spell this right. Quantity. There we are. What else do I want? Let's do our product supplier, and it might be useful. I mentioned this before, but to get from GitHub the page that has all of my table data on it, and it's a little bit easier because that's what I'm referencing. But I don't really have screen real estate to show it to you at the same time as I'm doing all this other stuff. So I'm going to say product, especially with this one, product name I want to go and get the item's price. Remember, I have the price information separate from the product. Anything else I'd want? Yeah, let's go and do a total. One thing to know, though, is you can't use total if you want this to be updated as the data changes. So, but I'll show you a fix for that down below. So we'll do sales, but let's just do it this way. Quantity. And let's multiply that times our item price. And then let's give this an alias of total. And don't forget to put your commas inside of here. Whoop, did I forget one? Yes, I did. So after company, put another comma inside of there. And let's do another concat. And you should remove concat if you also want this to be updatable. But for now, I'm going to have it be this way. All right. And then I'm going to say salesperson dot first name. And then like this. And we'll do salesperson like that dot last name. And it just as a heads up, what you basically would do is you just remove the total amount from this and remove the concat, get all the rest of the information except for that, and then call for that whenever you call for the view to show. All right. But either way, don't worry about that if it doesn't make sense. Let's go and give this also an alias. So I'm going to go and call this as, and we'll do salesperson like that. And what else? Let's come down here. We're going to go from, and do I need to do anything with that? I don't think so. So we'll say from sales order, and we're going to just join some tables like we did before. So we'll say join, and it's going to be sales item is the other table we want to join. Then we need to have our condition for how they join. So it's going to be sales item dot sales order ID is equal to the sales order ID. And of course, you know, this is just the tables joining together on sales order ID as well as the ID for the sales orders. And let's go and add another one. So let's do another join. Let's join item onto this. And how we'll do that is we're going to say item ID is equal to, make sure item ID is equal to, and sales item dot item ID. And I like to use this same format over and over again. So if I am joining item ID, to sales item, well, I know I just put dot and item ID after it. I think that is so much easier. So if I want to join sales order to the sales item, well, I just go and have my sales ID for the sales order table, and it automatically matches. See, everything just goes together really well. Let's go and get that. And after this, let's do some more. Let's do some more joins here just to make this even more complicated. So I'm going to say join customer. So let's also get the customer table into the mix here. And again, this is going to match up. And I want to match up my sales order with the customer ID that is inside of it. So customer ID equal to, and the customer ID, exactly like that. So I actually should have made this customer ID instead of cust ID, but either way, it's fine. And let's also join product. So we'll do product like this, and we need to say how. So it's going to be product dot ID is going to be equal to the item dot product ID. And let's do more. Let's do another join, and we'll say join salesperson and on the salesperson ID equal to the sales order dot salesperson ID, and that is just like that. And I think that's it. Let's do an order by now. So we'll say order by, and we're going to order by the purchase number. So we'll say purchase order number, like that. Okay, so we have all that set up. And let's run it. Is there an error anywhere? Doesn't look like it. Returned successfully. Okay, cool. And then we have that view stored inside of here. And you can see that it is stored. Here's views, and we called it purchase order overview. And you can see all of the column information that's inside of there. And what's really cool is whenever the data in the database is updated, so will this view, except for this concat and this total. And if you wanted everything else to be updated, what you would do is you'd have to separate this and put that inside of your queries. And another thing that's interesting is you can use the view in all the same ways you can use a regular table. So if you want to be updatable, another thing you can't do is you can never use distinct, union, aggregate functions like concat. You also can't use group by or having. I think that is every single thing you cannot use if you want it to be a view. And if you want to see the results of your view, you just go select like this and from and purchase order overview. So there's this. Let's just copy that, paste that down inside of there, put that there, select this and hit F5. And here you can see all of your awesome data all organized together in a really nice, easy way. Okay, so purchase order, the company and the supplier, the quantity, the name, all of that awesome stuff. All right, so really good stuff. Now, if we remove the total above so that it could be updated, we can just calculate this. Let's just go and get rid of it. And you can do the same with concat. So let's come in here and let's do purchase order overview. And let's just make this purchase order overview 2 or something. And let's get rid of the total part. So let's get rid of this, yank that out of there. And yeah, let's just get rid of it. Okay, so it's gone. So let's go and highlight this because we need to make this now. So we'll say F5, and that was created. And let's go and recalculate it using the total. How do you do that? You just say you want to select everything, but on top of that, you want to add some additional stuff. And what we're going to do is we're going to say quantity times the price, like that. And then we can say as total, like that. And then let's go and throw the from on the other one. And this is purchase order overview underscore 2 is what I called this. Let's select it like that and run it. And you can see we still get all of our same information, but this now is updatable because, well, we'd have to also get rid of the salesperson first name and last name. We have to list those in separate columns because we can't use aggregate functions. But other than that, everything else would work the same, and that would be really useful. And if you would like to, if you decide, I don't like these views, well, you can get rid of them also. You can just say drop view like that, and let's just run it. There we are. Okay, and the view has been dropped. All right, so now we're going to get really into the meat of this tutorial, and it's going to be built around actually creating functions. And there's going to be different ways of creating functions. First, I'm going to talk about creating functions using SQL statements. And then I'm going to go and cover pgSQL, which is very highly influenced by Oracle systems. So you can basically write programs just like you would in any other traditional programming language. Basically, the overview of an SQL function. Let's go and get it here. So here it is, and there you go. So you are going to have create or replace function like this, and these are going to be replaced. So let's get rid of that. Okay, get rid of that, and let's get rid of this also. So there's going to be a quote around this, which we're going to cover how to get rid of that and why that's a problem. So you're basically going to have create or replace function, whatever your function name is, returns, and if it's void, that means that it's returning nothing. Otherwise, you're going to put the data type you're returning inside of here as, then inside of quotes, but we're actually going to be using things called dollar quotes here very soon. We're going to put all our SQL commands, and then here you're going to define that you're using the SQL language. All right, and I think this makes more sense by just going and creating some stuff. So what I want to do is I want to create a function here that is going to receive two values, and it's going to return an integer, and it's just going to add some values together. So we'll have create or replace function, and I like to start off my function names with fn, and then I'm going to say add ints, and inside of the parameter area you're going to show what values you're getting. And I'm going to have this, you can just go and put int and int. Okay, that represents you're going to get two integers inside of there. Now, later on, we're going to actually put variables inside of there, but I just want to demonstrate everything. So, returns, and it does return something. And I'm going to put the return statement down here because I like it here. All right, what's it going to return? It's going to return an integer. So, let's just throw int inside of here, as, and then you have your quotes inside of here. And then I'm going to say select like that. And if you want to get the very first value that was entered inside of it, you can put a $sign and a 1. And if you want to get the second value, you can put a $sign and a 2. And there it is. And it is going to return back this addition right here that we have. So what we can do to actually execute this, well, first off, let's run the function. So let's run it. And this has to be two dashes for this to be a comment, but I'm just going to get rid of it altogether because we don't need that comment there. Do a select all and run it. Okay, so I created my function. And how you can say that you created, we're going to cover triggers later on. That's something completely different. Let's get rid of this. And let's go and close all these columns and tables and stuff. Okay, so we got rid of all that stuff. And if we go up here inside of functions, you can see it created my function. It's called function add ints, and it gets two integers. All right, so if we actually want to utilize it, we can just come in here and we can say select and then call our function. So function add ints like this. And let's say we want to add 4 and 5 inside of there. We can do so. We can select this, run it, and we can see our result down here is 9. All right, so that is the basics. Like I said, and everything's going to show up inside of our function folder. But I'm going to get rid of these quotes right now because you're never going to see them. And I'm going to use something called dollar quotes. And the reason why is very often we're going to want to use these single quotes inside of our SQL statements, and we can't do it this way. So what we can do is we can actually replace those with $signs. And I always like to put body inside of here. So let's get rid of that. And let's get rid of this and put body inside of there like that, because you can have some different problems. This is a basic dollar quote. Okay. I don't want that. You can use it, but there are circumstances in which that's not a good thing. So what I want to do here now is I want to go and just add in these values again, just to demonstrate that yes, indeed, you can do this. So I'll just leave this the way that it is, and we can come in, and because we have create or replace function, it's going to go and get rid of what we had before. So let's just go and run that, and let's go and select this and run it, and we get our same result once again, of course. Another thing, let's go and create a function that actually returns void. So what I want to do here is I want to check if a salesperson has a state assigned, and if not, I want to change it to the state of Pennsylvania. So I'm going to go in here and let's just select this, and let's call this something like update employee and state. And here, this is not going to return anything because it doesn't need to. It just needs to perform an action. Then inside of here, I can put my SQL code or my SQL statement. So I'll just input or tab in here, and I'm going to say update salesperson and set. And I'm also showing here how to do some additional SQL queries that I didn't cover elsewhere. I don't want to repeat myself too much. And I'm going to say where the state is null. So I'm saying if the state is null, I want to go and make it not null. Okay, so there it is. And we can just select all this and we can run that. And there we are. We created another function inside of here. It's not showing because this needs to be refreshed. So let's go here and refresh. And where is it? Functions right there. And now you can see that that's been updated. And then what we can do is we can just go and select this right here, copy, and jump down inside of the select area, which doesn't have any parameters. Oops, I just realized I left those in there. Let's get rid of them. There's no reason for that to be there. And let's go and select this. Now, because I changed the parameters, you're going to have another function show up inside of here. Let's just run it. Okay, so we got that. And just to show you that it's going to show both of them, even though, well, there are two. Okay, so let's do refresh. And if we come down here in functions, now you see that there is an update employee state with and without parameters. But this is perfectly fine. So I'm going to come in here like this, and I'm going to show you how to drop all these functions as well here in a little bit. So let's throw this inside of there, paste that inside of there, and this does not receive any parameters. Let's go over here, select that, and run it. And you're going to see that null comes back because there is no return. All right, well, let's do some more stuff. Okay, so let's say that we wanted to get the maximum product price. So again, we're going to just change some information up here. So let's go like this, and let's call this max product price, because that seems to be a good name. And in this situation, we're returning an integer. I normally just use numeric because that works pretty good for me, and it is going to represent a float value. And we can get rid of this whole entire thing right here. So I'll get rid of that, and I'm going to go select, and I'll use an aggregate function, which is max, and we'll get our price, and from item, and everything else stays the same. Let's go like this, run it, and let's go and call this function. So we grab this, copy, and paste this over here. It's not receiving any parameters either, so we can just select this like this, and F5, and you can see the maximum price shows up right there. All right, let's continue making some useful functions. So let's come over here, and let's say we want to get the value of our inventory. So we'll say function get value, and we'll put inventory inside of there. And here, that's going to be a numeric, so we'll leave it a numeric. Select, and this is going to be sum now. So let's go and get total of all of them for our item, and you could also go and throw a semicolon there if you would like. And let's go and select all this, and F5, and we created it, and then we can come down here and copy this guy right here and paste it inside and go and get our total inventory value. So like this, and there is our total inventory value. Let's say that we want to go and get the total number of customers. So let's go get rid of this, and let's call this number customers. And this, we can leave it as a numeric. It's actually going to be an integer, but we'll leave it as a numeric. Why not? And we'll say select and get rid of that. And here we're going to use count. And whoops, count. And we'll just throw in our star inside of here, but we're getting this from customer. So customer like that. And again, we can go run that. And we can go and get this, and we can use these functions and queries and everything if we would like. Throw this right here and select and run it. And you see that we have a total of 20 customers. Our business is not doing that great. All right, so let's go and do it a little bit more complicated. Let's say we want to get the number of customers who do not have a phone number. So I'll get number of customers, and I'll say no phone. Don't worry, we'll be getting into more complicated things. Again, leave it as numeric. Why not? Select from customer, and here I'm going to be using a where clause, and I'm going to say where the phone, if I can spell phone is null, like that. And run this, and we will get this. Oops, let's go copy this first. So copy and paste this inside of here, and then select this again, run it, and we see that we have telephone numbers for every single customer. So that's pretty good. Let's take it up. Let's say that we want to go and get a parameter this time. So let's say I want to get the number of customers from Texas and using a name parameter. And that name parameter is going to be Texas. So this is going to actually get the number of customers from any state. I'm just going to say that I just am interested in Texas. So I'll get number customers from state. Okay, so it's going to get anything. But inside of the parameter section, I'm going to put state, and I'm going to say, well, let's make it state name, because I'm obviously going to be getting the state from the database, and that would cause confusion. And I know that it's 2 characters, so I'm going to throw that in there. And what's it going to do? It's going to return a numeric. So I'm going to go and count from customer, where, and then this part just needs to change. So I'm going to say where state that they passed, or that is in the database, customer, or the table customer, and is equal to whatever name they threw inside of here. So I got all that. Let's go and select this. And let's go and paste that down inside of here. And then over inside of here, the parameter we're going to pass is Texas. And I don't remember if I ran that function or not to make it. Did I? I did not. So let's go and highlight it. F5, and now we can run it. And F5. And we see that we have 11 customers from the state of Texas. First off, let's go and say we want to get the total number of orders using a customer name. And very often, whenever you're doing things like this, it makes a lot of sense to very first create, or go and just use regular old SQL to verify this is going to work. So I'm going to say count like that, and I'm going to count, get a total count here, and I'm going to say from, and I'll do sales order, and I'm going to do a natural join here. So natural join with customer, and I'm going to say that I'm interested in where the customer first name. I'm just using specifics here in this situation, and in my function I'll actually pass in this name. So I'm going to like this, and Christopher is going to be the first name, and then I'm going to say and the last name, customer dot last name, is going to be equal to Jones, like that. And there it is. That's all I need to do. And if this works, then I know it's going to be easy to make my function work. So select it, run it, and I get 1, which is all. I only have 1 Christopher Jones, so it looks like it worked really well. Well, now what I want to do is I want to go and take this and put it up here inside of a function. So I'm going to say, what do I want to get? Let's say I want to get the number of orders from a very specific customer name. So I'm going to say get number, and let's get rid of this part right here. And I'm going to change that to get number orders underscore from underscore a specific customer. So I do not need to, well, it's going to just be a variable number of characters inside of here. So I'm going to say customer underscore f name, like that. And I am going to, of course, have to label this as a variable number of characters, then customer underscore, and I'll make this L name, and variable number of characters again. So just so you see that, because it's going to run off the screen here in a second. Do I need this part over here? I don't think I can stretch it over there and move it out when I need it. Okay, variable number of characters. What's being returned? Well, it's going to get the number of orders. So that's a numeric. Don't need to change that. And then we have this part right here. Well, I already did it here, so this works good. So let's just go and highlight this and cut it out of there. And we'll replace inside of here this. And then all we need to do is, I like to keep everything nice and organized, so let's go like this. And the first name is going to be equal to the customer first name that they passed inside of it. So I'll go like this is equal to, and paste this here. And then the customer last name, copy. And now we have a function that we can use to search for any customers. And that's all I need to do there. So that I know this works. So I'm just going to go and copy this right like this and come down here and paste this inside of our select area. And then what I'm going to pass inside of the parameters is Christopher and Jones. So we'll say Jones like that. Did I run this? I don't know. Let's just run it again just to be safe. There it is. It returns successfully. Run it again, and we see that we have one order from said customer, Christopher Jones. Let's say we want to return a row, and this is actually called a composite. And what do we want to return? Let's say we want to get the latest order. So I'm just going to call this get, and get rid of this part right here, and I'll say get the last order. There that is. And am I going to need any parameters? No, because I'm just getting the last order, nothing else. And I'm going to say here returns, and I'll call this sales order as, and then I'm going to come down here and I'm just going to get rid of all this because I don't need it. Okay, so I'm going to say I want to select everything from what? Well, this is returning a sales order. So guess what I'm getting? I'm getting a sales order. So sales order, like that. And I'm going to say order by time order taken. And we'll throw descending inside of there. And then do limit 1. And there it is. That's going to give me the last order. So I can grab this, copy. I can paste this inside of here just that easily. And I can go and get rid of this. And I can run this. And I can run this. Boom. And it's going to give me the last order. And it all comes out like this. So there's all this information, all the information I want, but it's not in a table format. So maybe I don't like it. I want it in a table format. So it's easy. Just put quotes or parentheses around this like that. And then just go dot and star like this. And if you do that, you can select it, F5. And now look at that. Everything is in a nice table format. What else could we get? Well, we could go and throw any of the different column names like time order taken and just get that individual piece of information. All right. So very useful stuff. Now let's say we want to be able to get multiple rows. So let's say I want to get all rows for every employee inside of California. Well, first off, let's go and verify that I can do this with SQL. So I'm going to say select everything, and I'm going to say from and salesperson like that, and I'll say where the state is equal to California like that. Okay, so I got this query, and if this works, I can use it in my function. And it looks like it did. All right, so that's good stuff. Everybody's in the state of California. Wonderful. Okay, so what are we going to do here? Well, create or replace function again. I'm getting the employees, so I'm going to get rid of this part. So I'll say employees, and I'm going to make it so that it works for any state. Employees location, and let's say location, and this will be variable number of characters they pass in. And what is it going to return? Well, it's going to return multiple rows. So in a situation in which you want multiple rows, you say set of, like that. And then what am I getting? Salespeople. Well, I'm using salesperson. So I'm getting a list of rows, set of rows from the salesperson table. So got all that. And I know this works because I got it down here. So let's just go and copy this and or cut it out of there and paste it inside of here. There it is. And the difference is I got my location here. So let's go like this and location. And then I can go and copy this guy right here. And let's go and what else am I getting? So let's keep this format. I like getting all that information. And let's go and put a star here so I can get everything in a table format like that. And in this circumstance, I'm just going to say California. Of course, I can do any state. I don't know if I ran this or not. Doesn't matter. I can just do it again. Query is good and run it again. And you can see here we got all of our employee information for employees that live in the state of California. And of course, we could change that to wherever else we have those different people. Oh, what else would I like to do here? Oh, well, I said that I could use these functions and queries, so maybe I should demonstrate that. So what I want to do here is I want to get the names and the phone number from this function. I'm only interested in the name and the phone number. I don't want anything else. So I can do select like this, and I can say first name and last name and phone. And I'm looking for from, and I'm getting it from this function right here. So let's just go and get this function name. And actually, let's go and copy the California part also. So there that is, from, paste that inside of there, put that there, and there we are. And run it. Boom. And now we get just the names and the telephone numbers for all those employees. Okay, so there is a rundown of how to create numerous different functions using SQL functions. And up next, I'm going to show you how to make pgSQL functions. All right, so now we're going to get into pgSQL. And it is going to be very heavily influenced by Oracle SQL. It's going to allow, this is the biggest part of the whole entire tutorial here. This is now going to allow us to loop, to use conditionals, functions, data types, and much more. And you can see the basic concept of laying out a pgSQL function. You go create or replace function, just like we did before. And then we're going to have function name, all the parameters with their types, returns, and the return types as here is our body tags again. And then we're going to have begin with all of our statements inside of here, end. And then we're going to have the end of these dollar tags. And then we're going to now define our language as PLPQ SQL. So let's start off by doing a real world type of example here. Let's just get rid of this part here. And let's say I want to get my product price by name. Well, first I'm going to just go and create a query to see if that works. So I'm going to say select item price, and then I'm going to say from item, and then I'm going to do a natural join, and I'm going to join with my product table. And then I'm going to say where the product dot name is equal to, and grand view is one of them I know. And then if this works, then I know I can create my function. So I'll just select that, hit F5, and you can see here that yes, indeed, I was able to get a result, $199.60. Great stuff. Now all I need to do is go and transpose this into the function. So I'm going to have a function name. So I'm just going to keep this abbreviated function. And then I'm going to say get and price product name, like that. And inside of here, I'm just going to call this, the parameter name is going to be prod for product. And then I'm going to have the type be here, variable. Oh, let's make this product name, make it a little bit easier. So I'll say product name. And then after that, I'm going to say this is a variable number of characters. And let's move the returns down to the next page. And this is going to be a numeric because it's a price. So I'll make that numeric as. And then we get to the begin part. So let's get rid of the statements here and actually put real statements inside of it. So what statements am I going to put here? And what else am I going to do? Well, instead, we're going to go and grab this guy right here and the whole entire thing. Let's just copy it out of there and let's paste it inside here. Now, you can no longer use select, and what we're going to use instead is return. So we'll say return item price from item stays the same, natural join product again, where product name is, and now instead of grand view, this is going to be interactive, and we'll be able to say product name. And then you're going to have your end, and everything else is perfectly fine. So good stuff. Now what we can do is to go and actually utilize this function, and we're going to be able to use this in all our other SQL queries as well, is we're going to come in and say select, and then paste in our function, and then we will do grand view. So grand view like that, and then we can select it, and we can run it. Whoops, something is wrong. No function matches the give. I forgot to run the function. Don't forget to run the function like I did. Okay, so let's go and select this first, and now we can run it, and now we can select this, and oops, what did I do wrong there? I see what I did. I put a Q inside of here instead of a G. Okay, select that again, and run it, and there it is. So that is a G, not a Q. And then let's select this right here, and let's run that. And now we see we get our same results, exactly like we expected. All right, so good stuff. Now what I want to do is talk about using variables in functions. So let's go and do another example here. I think I just want to go and just have this be simple and just get a sum. So what are we going to do? We're going to change this function right here into get sum, like that. And then it's going to have some different variables inside of here. So I'm going to have this be value 1, and it's going to be an integer, and value 2, which is also an integer. We don't need to space there. And what's it going to return? It's going to return an integer. So let's put that in there. As body begin, and what are we going to do? Well, what I want to do here is I want to have a declare block where I can put all of my variables inside of here. So you go declare. This is where you create your variables. And I'm just going to have this be the answer, which is going to be an integer, exactly like that. And this guy right here is actually going to go before we have our begin block. So we're going to copy that out of there, paste that inside of there, and let's just have it be at the same level of indentation. That's perfectly fine. And then what we can do is let's just get rid of all of this, and we can say answer, and you're going to use this colon equal to assign this value, and it's going to be value 1 plus value 2. And then, quite simply, you can just say return like this and our answer. And there it is. So we got all that created, and we run it. Everything looks good. And then we can come in here and grab this guy right there, copy it, and paste it inside here. And then we can go and throw some values inside of there and see if it worked or not. And I'm just going to say 4 and 5. That seems good. Let's run it, and boom. And you see we get a value of 9. So that works great. So that is how we are able to assign variables inside of here using our declare block. Now what I'd like to do is assign a variable value with a query. So what do I want to do here? Well, let's say I want to get a random number and assign it to a variable. So let's just come in here again, and I'm going to say get random number. It's a useful function. And what it's going to have inside of here is it's going to have a minimum value. Can't put min inside of there because that is a aggregate function, so I can't do that. And we're going to say our maximum value. Both of them are going to be int. And then we're going to say, what's it return? It's going to return an integer. Again, inside of the declare area, we're going to have a random value, which is also going to be an integer. And then down inside of here where we put our statements, I'm going to say select, and I will call our random function like that. And I'm going to multiply it times our max value minus our min value. And then we say plus min value. And we're going to put that into our variable called rand. And then what we can do is just come in and say return rand exactly like that. Everything else here stays the same. And it's also common, put a semicolon after that, but as you saw, you don't need to. And there we are. So let's go and generate a random number. So we can go copy and paste this inside of here. And we need to define our minimum and maximum. And let's say something like 1 and 50. Looks good. And I know I didn't run this, did I? Don't believe so. Let's run it. Everything seems to compile perfectly. And run this. Get a random value of 52. And we can run it again. 25, 45, 29, 19, and so forth and so on. So that looks like that is looking very good. Okay, in the next function, what I'd like to do is I would like to get a random salesperson name. And what I want to do here is basically just go through an example where we store rows and variables. And also I'll use the concat function. Okay, so what are we going to do? I'm going to say that I want to get a random salesperson. So let's say somebody calls, they don't have a salesperson currently, and we want to generate a random salesperson for them to, give them a potential sale. So get random salesperson returns. Well, this is going to be a variable number of characters as, and inside of declare, am I going to want to put anything? Yes, I'm going to want to have a random integer inside of there. And what else am I going to do? Well, I am going to use a record type to store row data. So I'm going to do employee, and this will be record. And then down inside of here, I am going to want to generate a random value. So I'm going to say, let's say I have 5 employees. I could have passed in the number of employees and all that, but I know I have 5 employees. So let's just keep this very simple. I'm going to say 5 minus 1, and then I'll say plus 1. And there that is. And we're going to store that into the variable that is called rand. Then I am going to come in here. Let's go here. And I want to get row data for a random salesperson. So I'm going to say select and everything from where, from sales underscore person. And I am going to say that I want to put those into the employee record where their ID is equal to my random value. Then, after I do that, I want to concat the first and last name and return it. So I'll say return and concat, and I will get my employee first name, and then I'll put a space between it and get the employee last name. And there we go. All right, so got all that set up, and let's see if we did a good job or not. F5, look at that, created the function, looks good. And then we can come up here and just call this right here. So copy, and we'll paste this inside of here. It does not have any parameters. Whoops, what did I do? Yeah, let's just paste that there. There we are, get random salesperson. And let's go and get rid of this. And we'll run it and see if it looks like it works. So we got Jennifer Smith, and we got Jennifer Smith. Why are we getting Jennifer Smith? Oh, there we got Brittany Jackson. So yes, it's totally random and looking good. All right, so that is how we can go and get a row of data. And we're just going to store it, like I said before, inside of a record type. All right, what would I like to do now? I'd like to demonstrate in, out, and out. And these are going to be used instead of returning types like we have done before. So I'm going to just do another one where it's just going to be a simple summation. So I'll go, this is going to be get sum 2, and we're going to label this as a in variable. So I'll say in v1, and it is an integer, and then another in v2, and it's also an integer, and then we will have out, which will be our answer, and it's also an integer. So then in this circumstance, we don't need the return type, so we'll get rid of that, and it'll just be as. Here is our body section. We're also not going to need to declare anything, so let's get rid of that. And then this, quite simply, is going to automatically return our answer for us. So we just go and assign the addition of these two values to each other, and that automatically is returned to us. And that's it. That's all we need to do for that. And then we can come down here and go get, and I'll just write this in, sum 2, like that. And then we'll pass in 4 and 5 again, just like we did before. Let's go and run this function. Boom. Everything looks like it compiled. And we'll run it again, and we see we get our answer. All right, so there is one example of using in and out. Let's go and do a couple of them. Like, let's say, for example, I wanted to get multiple out values. So for this, what I want to do is I want to get my customer's birthday. So I'm going to come in here, get rid of that, and I'll say customer birthday. And I'm going to have an in variable, which is going to be the month. So I'll say month, in month, looks good. That's an integer. I'm also going to, well, let's get rid of the rest of these. So I'll get rid of that. And I'm going to say out is going to be birthday month. And that's also going to be an integer. And then I'll have another out, which is going to be birthday day, which is also going to be an integer. So there's multiple out values this time. Also, what else would I like to do? Well, I probably would like to get a name or something. So why don't we go and actually put these on separate lines. So I'm going to put a comma inside of here and bounce down here. And I'm going to say that I also want to get the first name. So we'll say out and f name variable number of characters, and again out last name variable number of characters. And we have as again, body stays the same, begin stays the same, but we're going to have a little bit more complicated type of statements inside of here. So what I want to do here first is I want to select my month, my day, my first name, and my last name. So I'm going to say select, and if you don't remember it, how we go and get the month from a date is we say month from, and we have the birth date on file, so we'll say birth date, and then we'll say extract, and we also want to get the day from birth date, like that. And let's go down to the next line. I'd also like to get my first name and my last name. And this, all of these are going to go into, you have to list the variables where they are going to be stored. So I'm going to say into BD and month and BD, obviously the order matters, and also F name and L name. And they are going to go into all of these out values that we have defined up here inside of our parameters. So, and what are we going to do now? Well, we're going to say from, and we want to get them from our customer table. And then we have our conditionals. So I'll say extract month from birth date. So I'll say birth date and equal to the month that was provided to us in our in parameter up inside of here. And let's say I just want to limit this to 1, and also that this needs to end, of course. All right, so did I do all that right? It looks like it. Let's run it. Uh-oh, there is an error. Month from birth date. And this is not closed off. So that's the reason why I got that error. And let's go and run it again. Did I make that error twice? No, it doesn't look like I did. Okay, so I just forgot that little parentheses. Let's run it again. Another error. Last name, line 7. So I have my first name and I have my last name here. What did I do wrong? I have an extra parentheses. There's the one that was missing from before. Okay, let's run it again. And that time it worked. Okay, so now to get it, let's say I want to get the very first customer birthday who has a birthday in the month of December. So let's go get rid of this, paste that inside of there. Whoops, forgot the FN part. And I'll say December like this. So there that is, and we will select it and run it. And we see that, yes, Lauren Wilson has a birth date on the 26th of December, and that's great. Okay. Another thing that we would like to do is to return query results. So how can we do that? And how do I want to do it? Let's say I want to return salesperson data using a query. So what am I going to call this? I'm going to call it get, and I'm going to call it sales people. And I'm going to get rid of the ins and outs and all this stuff. Let's not get rid of all of our parentheses, though, because that can cause some problems. Okay, so do I need to pass anything in? No, I don't. Okay, so what would I like to do here? So I'm going to say returns, and we say set of, like we did previously whenever we had SQL functions. And the set of things I want is going to be salesperson. So we're going to be using the salesperson table and information to get these query results. So what do I want to do? As body begin, and here what we're going to do, I'm just going to get rid of all of this code, and I'm going to say return query like this. Very simple. And then I can say select everything, and let's go into the next line from the table name. So this will be salesperson like this. And that is all that I need to do. So I have that end there and all that looks good. So let's go and copy this. And then let's come down inside of here and paste this inside of there. And remember, there are no parameters. So let's get rid of that. And let's run our code just to make sure that it compiles. Everything looks good. And I want to go and get my salespeople. Now, can you remember what the results were before? Not exactly what we wanted, but you can see here is all of our employee information. However, it's all crammed together. So how do we go and get it in table format? Just put parentheses around it, just like we did before. So dot, and let's throw a star there. And this will give us all of our information in table format, just like it did. And let's say that I specifically want the street or something like that. Let me just go like this and go street. And we'll run it to get an individual cell. And there we go. We got all that also. Okay, so let's go and continue to make this more complicated. Let's say we want to return specific data from a query using multiple different tables. How can we do that? What do I want to do? Let's say I want to get the top 10 most expensive products. Well, this is a little bit more complicated, so I'm probably going to issue a query here first just to make sure that I can do it. So I want to go and I want to get my product name, and I'd also like to get my product supplier, and I'd also like to get my item price. And once again, I'm referring to the code that I have on GitHub here to read the names off the table. So it might help if you're watching this to get that. It's free, of course, so I'm not selling anything. All right, so I want to get this from item, and I'm going to have to do a natural join with product. So I'm joining the item and the product table. Anytime I do this, I need to, whoops, yeah, that's fine. I need to go and do an order by, and I'm going to say that I want this to be the price, and I'm going to say descending order. And I said that I want the top 10 most expensive products, so let's say limit and 10. Does this work? Let's go and run it. And it looks like it did. Looks like about 10 products. Yes, there's 10 products, 1 through 10. All right, and I also got the price, exactly what I wanted. Okay, so now I know that works, and now I can create my function. All right, so what am I doing here? I am returning a query using multiple different tables. So what am I going to name this? I'm going to name this get, and of course you could go and have a parameter and that would say the top 20 or whatever. But I'm just going to use the top 10 because that seems good. Expensive, and let's make it a little bit more descriptive. Let's say products. Now what we do is we say we're returning we're going to still need our as part here, but we're going to say returns table this time. And then we define what is going to go in the table. Let's bring the as up here like that and go here and put that there. Okay, good. And then we'll say tab. And what are we going to return? We're going to return a name, which is going to be a variable number of characters. And we are going to return a supplier, also variable number of characters. And this is our custom table we are returning with just the information we want. And a numeric, don't need a comma after that. Then as body, begin, and we're going to keep the return query part here. And we're going to keep a lot of this. So we'll say select, and what are we going to get? We want our product name, and we want our product supplier. So there that is. And we want our item price. So we got all the different parts we want. What are we going to do? We're going to use our item table. We're also going to be using a natural join here. So let's get rid of that semicolon. So we'll say a natural join, and we're going to be joining with the product table. Obviously, we need product and item. We have item, there's product. And then I want to go and get the top 10. So that means order by, and this will be item dot price descending order. And then finally, limit 10. All right, let's see if we did all of that correct. So let's go and select this, just this part right here, and let's go and run it. And it says it returned successfully, so that looks good. And then we can go and just call our function. So we'll go get this guy right here, copy, come down here, and go and paste it inside of here, just like this. Oops. Just like this. Don't need the parentheses, I don't believe. And in this circumstance, yes, I want this to be in table format. So let's go and select this, run it. Could not identify. FN get 10 expensive products. Did I actually FN get 10 expensive prods? Yes, I did that. Didn't I run this function? I thought I did. Let's run it again. And let's go F5. Yes, create function. Looks good. Oh, street. I don't want street here. I want to replace street with just a star. And let's get this and run it. And did we get it? Yes, we got our name, supplier, and all of our products. And they are in descending order. So it looks like, yes, those are the top 10 most expensive products. All right, so now up next, what I'd like to do is go and explore if, ELSEIF, and ELSE. So what I'm going to do here is we don't need this right now, so let's get rid of that. What I'd like to do is go and look at the current orders that we have by month, and then shoot out like a little piece of information that says whether we're doing good order-wise or bad order-wise. So what am I going to call this? Let's call this function and check month orders. So we'll say, there it is. And of course, we need the month that we are searching for. So we'll just call this the month. And what are we going to return here? Well, this is going to be much more simple. Let's get rid of all of this stuff, because all we're going to do is generate a message that is going to print out on the screen. Variable number of characters as, in this circumstance, I am going to, inside of here, before begin, I am going to declare a variable, and it's going to be total orders, and that of course is an integer because we don't have fractions of a of an order. So let's get rid of this. And how am I going to check my orders? Well, I'm going to say select, and I'm going to use the function count, and I'm going to say purchase order number. So we'll go get that, and I'm going to be storing that value into the variable called total orders. And then after that, what I can do is I'm going to, of course, say that I'm going to get this from sales order, like that, and where, and I'll go and get our month, extract month from, and time order taken, and equal to the month. Right, like that. All right. Now what I can do is I can use conditionals to provide different output. So I'm going to say if total orders is greater than 5, then obviously selling 5 pairs of shoes in a month is not good, but we have a limited number, you know. So this isn't 100% reality we're living in here. I tried to keep it all very simple. So what I'm going to do here is just say concat, and I'll say total orders. That is the variable that I'm working with here. So total orders underscore, like that. And then I'm going to put a comma here. And then after that, I'm going to put in quotes orders, and I'll say that this is doing good. Doing good, even though it's not, but you know. Okay, so after we do this, we can then do else if and total orders, and we'll say less than 5. Well, then we will shoot out. We're basically going to do exactly the same thing. So let's grab this, copy and paste, and there we are. Concat total orders, and we'll say orders, and we'll say doing bad. And then after that, we will say else, and we will return another statement, and we'll say something like on target. So on target. All right, I think I did everything right there and everything. Oh, one thing you have to do, very, very important. Anytime you put if inside of here, you have to end that if conditional block with an end if. Exactly like that. And everything else is exactly the same. So let's highlight this, and let's jump up here, and let's run it. And created function successfully. Good. And we can come in here and check our orders. So we'll go and select all of these, copy, come down here, and then to get them, just like before, we say select, and we pass in our orders, and we'll say that we're interested in the month of December, and we'll come in and we'll test to see if it works, and the message that was sent back is doing bad, so not good, and it says 4 orders. So I should have also put a space right here for all of these, but that's okay. I think you'll forgive me for that. All right. So there we have our if, else, if, and else statements. What I want to do now is I want to go and basically do exactly the same thing, but I want to use the case statement for it. So what do I want to call this? We can just leave this be the same, leave this be the same, all of that be the same, total orders also the same, and then select count, purchase order number, that's fine, into sales orders, that's fine, from sales order, also good, where extract month, time taken, also good. The part that needs to change is this part, because we're going to be using case statements instead. So basically, case executes different code depending on an exact value. So what we're going to do here is just say case like that. And then, of course, I'm going to do it up front. I'm going to say end case. You have to end a case statement block like that. And then I'm going to say when total orders is less than 1, then I am going to, I should have kept the return statement, but that's okay. So I'll say return concat, and we'll do total orders underscore, this is a variable, and like this, we won't make the same mistake. We'll put a space in this side of there instead. So we'll say orders is equal to terrible. All right, so that's what we have for our first output. And then let's come down here, and then we'll say when total orders is greater than 1, we can go and stack these conditionals with a logical operator and inside of them. Total orders is less than 5, then, and we'll go and use this again. So let's go and copy it, copy, and come down here and say paste. And we'll say in this circumstance that this is on target. So on target, like that. Then what you do is if you want to have a default that if it doesn't meet either of those conditions, then you say, some languages actually use default, but here we're just going to say else, and we'll say orders, and we'll say doing good. All right, so there's all that, and we can go and select it, and of course always have the end for your case. Let's run it. Said the function was created. Everything looks good here. Whoops, I don't need this. Get rid of this little guy there, and check monthly orders is the name of it. Run it and check monthly orders, and it says on target. We have 4 orders and we are on target. Does that make sense with what we have? Yes, on target. All right, good stuff. Okay, so now what we're going to do is we're going to get into looping. So the basic concepts of, there's multiple different ways to be able to loop, but the basic idea here, if I throw in some multi-line comments, is this is the basic concept of looping. You're going to have loop, you're going to have statements, and then you're going to exit when a condition is true, and then you are going to end your loop exactly like that. So let's go and think of something I can do. Maybe let's just do a simple loop test. So I want to sum values up to a maximum number that is passed into my function. So this is going to be function, and I'm going to say loop test. And it is going to be passed in a maximum number, which is going to be an integer. Returns, it's going to return an integer in this circumstance. And what are we going to do? Are we going to declare anything? Yes, we have to declare some things. So I'm going to say this is J, and it is an integer, and it is going to get a default value of 1. And then we are going to have a total sum, and it is also going to be an integer, and we will have it start off with a default value of 0. Then we are going to go and loop some stuff. So let's get rid of all that stuff right there. And instead, we're going to say loop. And then anytime you define a loop, you also have to end it. So end loop, just very good practice to do that up front. And then what am I going to do? I'm just going to continue adding values to sum. So assignment operator is going to be total sum plus whatever j is 1 in this circumstance because that's what I said it was. And then I'm going to say j colon equal to j plus 1. So we'll just continue adding 1 to it. And then we have our condition. So we're going to say exit when and j is greater than the maximum number. And there that is. End loop, all that's good. And we can grab this. And this is function loop test. So let's go and first run it. And then we'll go function loop test like this. Copy and paste it down inside of here. There it is. And what do we want to do? Let's start with a value of 5, for example. So let's go put 5 inside of here. And we'll run it and run it. Uh-oh, control reached end of function without return. What did I do wrong here? Oh, I forgot to say return total sum. So after our end loop, I'm going to say return. And what are we returning? The total sum, exactly like that. So let's run our function again. F5, there it is. And let's run this down here. F5. And we see we get a value of 15, and that is exactly what we expect to get. Now I'd like to talk about the for loop. Now basically with the for loop, you're going to have a counter. In is going to be a command or a keyword, and then you're going to have your starting value, 2 dots, your ending value, by. Then you can define stepping. So let's say you wanted to do every other value. Stepping is going to be how much you add to this value as you cycle through your looping. And then you're going to have your statements, of course, and then, of course, also your ending loop. So what do we want to do here? Let's go and get rid of this. And let's say we want to go and just sum odd values up to a maximum number, okay? Just to do something slightly different. So what do I want to call this? Let's call this function for test. There it is, and we have a maximum number, returns an integer, all that's good. Are we going to declare anything? Well, we don't need this guy now because this value we are going to be using as a counter is going to be built into our for loop, so not needed. And let's go and get rid of, let's say, what do I want to get rid of? Let's go, that's going to stay the same. And we don't need this part right here. And we are not going to be using this exit statement. That's only used for our looping. But we'll come after begin right here. And I'm going to jump in and I'm going to say for I in, and then you define the minimum value, dot, dot, and the maximum value. And we're going to say that we want to go and increment by 2 every single time. Loop is going to stay the same. Total sum, this is all the same. This needs to be changed into an I, however. And the end loop is also going to be the same. So let's get rid of that. So there's end loop. And we're also going to return a total sum. Everything else is exactly the same. So let's go and run it. There it is. And then let's go and test it. So we'll just change this to function for test, exactly like that. And what do we want to do? Let's just leave it be the same way and run it. And we see we get 9 as an answer, exactly like we would think. Remember, all we're doing is summing the odd values. So that's the reason why it's less. And one thing to remember is you can also count in reverse. And to do that, what we would do is we would say for I in reverse, like this. And the only thing is you would have to have your maximum number be first, like this, and dot, dot, like that. There's the 2 dots, and 1. And this will actually give you exactly the same results, as you can see, because we're doing the same operation, we're just doing it backwards. So we can run that again, and come in here, and run that again, and you see you get 9 again. All right, so good stuff. Now what I'd like to do, I'm going to show you a do block, just to show you something, a different way of doing things. So this is a do block. You just say do like that. And then we can come in and have our dollar tags and do another dollar tag like this. And then we are going to come in and declare some values. What I want to do now is I want to do, basically I want to output all of my salespeople's names using a for loop. So I'm going to say declare, and I'm actually going to print them out here as messages to my console just to show you something else different. So this is going to be a record. And if you made it this far into the tutorial, please take just a second to tell me in a comment. Just say, hey, I made it. All right, and helps me a lot to know that somebody is actually watching these videos. All right, so they take a little bit of time to make. So what I want to do is output my first name and last name like this, and I'm going to say from salesperson, and let's say I want 5. I think I only have 5, and I'll get an error if I have more than 5. So I'm going to say limit 5, and then I am going to come down here and I'm going to say loop like that, and I'm going to output a message. So I'm going to say raise notice like this, and what you can do is inside of your quotes you can put this little % sign, and it will tell you, it will actually put the variable values inside of here. So I'm going to use my record, I'm going to get my first name, and then you go record and last name, and that will output that to the screen. And at any time you have a loop, remember you must end your loop exactly like that. And then we also need a final end for our begin statement we have here. Everything else is looking good though. Oh, and one other thing, you need to define your language. So language, and this is pgSQL. And that's good. So let's go and select this and let's run it. And you can see right there in the messages section now it is printing out all of our employees' names. Okay, so interesting. Not just another tool we can use. Now what I'd like to do is cover for each, and also why don't I cover arrays. Why don't I just do this inside of a do block as well? So basically the way of using for each with an array is going to be this concept. So let's get this up here. Dot, dot, like that. And there your basic layout for this. So what do I want to do? I want to print all the values inside of an array. So let's just get rid of that, because I don't think you need to see it, because you're going to see it again in a second. So we're going to have body, we're going to have declare, and we want to create an array inside of here. So how you create an array is you just say, I'm going to call this array 1. You define what the data type is that you're going to be using. You're going to use your array, and then you're going to use your assignment operator, array, and you're going to put in whatever you want inside here. Let's say 1, 2, and 3. And there that is. And then I don't need record here, so let's get rid of that. Bring this up here, and I'll just have this be an integer named I. All right, so we have begin. And here we're going to be, let's just get rid of, well, I still need the loop, and I'm going to use a raise notice also, but in this circumstance, I'm going to use for each. So let's just get rid of all that, and let's type in for each, and I is a temporary holding cell for each value that we're going to pull from the array. And so we'll say I in, or like this, and you have to say array, and then whatever the array name is. And then after that, we have our loop. Let's just leave the loop be like that. And then we'll have raise notice, and we will just put that there. And then this can just be I. It's going to output all of those values. So in loop, end for begin, and end for the body, and all of that else, all that other stuff looks good. And let's run it. And you can see that it goes and outputs everything exactly as we would expect. Now let's talk about while loops. Okay, so what do I want to do with this while loop is I want to sum values as long as a condition is true. So I'm going to say do, body, declare, and let's go and get rid of all of this. We're not going to be using arrays this time. And I'm just going to have this be a counter. So I'll say default, and it's going to have a value of 1. And I'm going to have a total sum int and default, and this will have a value of 0 from the beginning. And then for our while loop, let's just go and get rid of this part. We're going to be using a loop again. We'll say while j is less than or equal to 10, we are going to loop. And while we are looping, we are going to say total sum, and the assignment operator equals the total sum plus j. And then each time through, we'll use the assignment operator to increment the value for j. And the loop then is going to end, and then we will do a raise notice to output this. So we'll say raise notice and like this, and output our total sum like that. And there it is. So very easy, quick way. That's one of the reasons you use a do loop, is to just go in here and a do block, just to go in here and test code. Works pretty good. Another thing I haven't covered is continue. So let's say we wanted to print the odd numbers from 1 to 10, for example. Well, what do we need to have here? Let's change this to I just for consistency reasons and have that be a value of 1. Let's get rid of this right here. And we're just going to do a simple loop and show you how continue works. Basically, what continue does is it's just going to jump back to the beginning of the loop. All right, so that is it. So we only want to print odd numbers from 1 to 10. Let's go and get rid of this, and let's change this to I, and let's change this to I, and then we're going to define when we are going to exit. So we'll say exit, and when I is greater than 10. Then what we can do is we can say continue when, and we'll use our mod function here. So we'll say when mod, and whatever the value of I is currently, divided by 2 is equal to 0. So that means that it is going to be an even number. So that means if it's an even number, it's going to skip back to the top of the loop. But we've already incremented the value of I, but what we're going to do now is actually print out what will end up being only odd numbers, because it won't get to this part because it, it says it's even. Okay, jump back to the loop. Don't do anything else that is inside of this looping block. So we'll say raise notice if it is an odd number, and we're just going to say number is equal to, and throw a percent sign inside of there, and whatever the value of I is will print. We are not going to have the raise notice down here this time. Then we end our loop, we end our whole entire begin block, and everything else is good. It actually probably makes more sense to also indent this, but we could indent this as well. So we could say tab, tab, tab. Makes more sense, looks easier to read, but I think you get the point. Select it all, run it, and you can see it only prints our odd values. I think now what we're going to do is go back to some real-world examples. I just wanted to demonstrate how the do block works. Okay, what we're going to do this time is we're going to return inventory value by providing a supplier name. So I'm going to come in here and change this function name, and let's call this get supplier value. I think that makes sense. And we'll change this to, let's change both this because it's going to be a variable number, variable character. Okay, so the supplier, variable character. And what are we going to do? What's it going to return first? Well, it's going to return variable character. We're going to concatenate the supplier's name with the actual value of the inventory for that supplier. So body, also good. Declare. Are we going to declare anything? Yeah, we're going to declare some stuff. We're going to have our supplier name, variable character, and we are also going to have, let's call this price sum, and it's a numeric. Then down in the begin block, we're going to get rid of all this, and we're going to say select product dot supplier, and we are going to sum the item price. And do we need to do anything with those? Yes, we need to put them into our variables. So we'll say into supplier and into price sum. And we are going to be pulling those from product and item. And the condition is going to be where product supplier is equal to the supplier. And we need to group by the product supplier so that we can do that sum. And then we are going to, this is actually going to have a semicolon here. Then we're going to have our final statement, which is what we're returning. And we're going to concatenate our supplier name, and with some text we'll have something like inventory value, and let's put this here and a $sign, and then after that we're going to have our price sum like this. There that is. End, body ends, this ends, all looks good. Let's select it. Let's see. Supplier is not a known variable. Into supplier. What did I call it? Oh, I called it supplier name. Do I want to just call it? Well, let's just keep it consistent. So let's say, let's just change. No, because I have supplier other places. So we'll say supplier name. This is fine. Okay, so we have all that the same. Let's go and run it again. Whoops, hit the wrong button. There we are. Query returned successful. And then we're going to say that we want to get a supplier value. And I'm actually realizing I can't think of one. I think I have Nike inside of here. So let's throw this here and Nike. There that is. And let's go. We can get rid of this right here. And let's run it. And let's see the total value of our Nike inventory. And let's go and get this, and that's a lot. $21,694. Okay, so there you go. And that is just a rundown of a lot of what you could do with pgSQL, the core concepts. And what I want to do next is talk about something called stored procedures. All right, so now we're going to talk about stored procedures, and I'm going to give you a bunch of examples. Basically, stored procedures can be executed by an application that has access to your database. And stored procedures can also execute transactions, which you cannot do with functions. Procedures, however, traditionally can't return values, but there's a workaround using in and out, which I'll show you. Procedures also can't be called by select. You can execute them with execute, which I'll show you. And we're going to be able to use parameters whenever we use that execute command. Also, you're going to be able to use call to execute them. And also, if a stored procedure doesn't have parameters, it's called a static procedure. And those with parameters are called dynamic. And you can see the basic layout of a stored procedure. Very, very similar to what you have with functions. What I'm going to do here first, however, I'm going to get rid of this line, and I'm going to come up here and I'm going to create a sample table that is going to store customer IDs with balances due. So let's say that that's something that I decided that I wanted to do. And I'm going to call it past due. And inside of here, I am going to have an ID, of course, and it will, of course, be serial. And it will be a primary key. I'm going to also have a customer ID, integer, and not null. And I'm going to have the balance that they owe our company. And I'm going to say that this is a numeric, and total length is 6 and 2 decimal places. And this is also going to be not null. So let's go and create that table. Just select it, and there we go. Whoops, what did I do wrong? Oh, I forgot to write primary key. So primary key. There we are. Now it'll be fine. Run it. There we go. Okay, so we have that set up. And is it showing over in our tables area? Probably not. Our functions aren't updated, so yeah, probably not. So let's go and refresh everything here. And let's look in schemas, and let's look at all the functions we have now. There's a lot of functions. That's how many functions we created. And more are to come. And tables, and let's look and see. Past due, yes it is. It's right there. All right, good. So we know we created that table, and we're ready to go. Now, what I want to do here is I'm just going to get some information on my customers. So I'm going to say from customer, like this. Whoops. And let's go and run this little guy. Okay, so we got some customer information. And what I'd like to do here is I'd like to get, I know I got customer 1 and 2. So let's go and place this inside of here. So I'm going to say insert, just throwing in some junk data so that we can play around with this. And I'll say past due, and customer ID is going to be passed inside, and balance, like that. And I will go and throw some values inside of it. So I'll say values and 1, and we'll say 1, 2, 3, 4, 5 is how much they owe us. And then, of course, 2, 3, 2, 4, 50. And there we go. And we can throw this into there as well. There that is. And then we can say select everything from, just throw it on one line because it's simple. Past like this. And just to verify that that information's in there, I know it's in there. There it is. Okay, so we got that. Okay, so now let's create a function here, or a stored procedure, I guess I should say. So what am I going to call this? I like to start stored procedures off with PR, and I'm going to say, I'm going to create a function that is going to be called debt paid. And what it's going to receive is, let's go and get rid of that. Let's get this. There we are. So get rid of that and throw this on the next line and tab this in. I'm going to have past due ID, and it's going to be an integer, and I'm going to have the payment amount, and it's going to be a numeric, as body, all the same. Do we want to declare anything? We don't want to declare anything. I'm just going to leave that blank for now. And down inside of my begin block, where I'm going to put all of my statements, I can move this up so you can see everything here all at once. And also, this doesn't need to be on that line. Let's move it up just to have some space. Okay, so what I'm going to do is I'm going to say that I want to update my past due table, and I want to set the balance, the new balance, to whatever they paid. So this is going to be a function that is going to allow the user to go and update that past due table. And I'm going to say where the ID is equal to the past due ID that was passed inside of here. Then what you need to do is after this, you need to say commit to run this update, and everything else ends exactly as you would expect. So now what I can do is I can go and call this. So I can get this, and if you remember, it was 1, 2, 3. See, 1, 2, 3, 4, 5 is how much customer 1 had as a balance. We can then say call, and there is the PR debt paid. And let's say that we want to pay off part of the ID for 1, and it's going to be $10 is how much they pay us. So let's go and let's run that. Did I run this? I don't know. Let's select it again and run it. Yep. No, I didn't run it. And let's go and do this, and boom. Okay. So that all looks like that worked. And now what I'd like to do is come in here and actually check it. So I'm going to say select everything from past due, like that. And let's go and run that to verify that it worked. And you can see this used to be 1, 2, 3, and now it's 1, 1, 3. So yes, indeed, that worked out for us. Let's also, also, if you would want to be able, I said that if you would want to be able to do return values, that normally is something that is not available to you. What you could just simply do is just use an INOUT, just like you did previously. So I'll just leave that to you to play around with. So that is how we can return values. All right, so that's a basic concept, and everything else is basically the same for working with these procedures as you had with functions, except now what you're going to be able to do is actually update data. And what I'd like to talk about next are triggers. Okay, so basically triggers are going to be used when you want an action to automatically occur when another event occurs. Common events include things like using commands such as insert, update, delete, truncate, and triggers can also be associated with tables and foreign tables or views. And I'm going to show you a whole bunch of examples, of course. And basically, triggers can execute before or after an event executes, and triggers also can execute instead of another event. And also, you can also put multiple triggers on a table, and they execute, just so you know, in alphabetical order. And they can't be triggered manually by a user, and triggers also can't receive parameters. And another thing to know is if you have a trigger that is row level, which we're going to cover what row level means here, the trigger is called for each row that is modified. And if a trigger is statement level, it will execute once, regardless of the number of rows. One thing that is really important to understand is when can you perform certain actions with triggers. As you can see on this table, it's going to show what triggers can execute based on when they are to execute. So for example, if a trigger is to execute before, if an event is insert, update, or delete, it can perform actions on tables if row level, and on tables or views if at statement level. Don't worry if this doesn't totally make sense. When I show you some examples, it will. Now, the pros of triggers is they can be used for auditing. So if something is deleted, a trigger could save it in case it is needed later. They can be used to validate data, make certain events always happen to maintain integrity of data. They can ensure integrity between different databases. They can call functions or procedures, and triggers are recursive. So a trigger on a table can call another table with a trigger. The cons of triggers is that triggers add execution overhead, and also nested or recursive trigger errors can be very hard to debug. And on top of that, they are invisible to the client, which can cause confusion when actions just simply aren't allowed. You can see here the basic idea of using triggers. And what I want to do here is basically what happens is you're going to have a trigger function, and it is going to look like this. And then what you're going to do is to actually create the trigger, you're going to have a statement that looks like this. And in this situation, remember I said before or after, and I showed the table, and we're going to have our events. And your event is going to be normally either insert, update, or truncate. This should be truncate. Truncate. There we go. On table and for each, and you're going to see an example, and it's going to make everything make much more sense. So let's just come in here and let's get rid of all this. So what I want to do is I want to log changes to a table that is called distributor. So let's say I have a table and it is called distributor. And what we're going to do is we're going to update if the name of the distributor changes and save that as sort of a log file. So I'm going to go ID, and this will be serial, and this will be primary key, and it's just going to have a name, and we'll say variable number of characters, and we'll have something like 100 or something like that. Did I close off all of this? Yes. So this is going to create that table, and you'll just have to, boom, there it is. We created our table successfully. All right. So now what I want to do is I want to insert some distributors into this. So I'm going to say insert into and distributor, and I'm going to put, name. That's all we're going to put inside of there. That's all that's there. And values. And then inside of here, I'm actually going to use some real ones. So here is a distributor name, comma, and another one. So J and B sales, and let's throw in Steel City Clothing. Okay, so there we go. And those are going to be some values we can throw inside of our table and then change them. And just to verify that they are all there, I'm going to say select everything from distributor, like that. And let's run that. And yes, indeed, they are all there. Okay. So now what I want to do is I want to create another table. And what it's going to do is it's going to store changes to a distributor. So let's get rid of that. So it's going to have an ID. It's going to have a distributor ID. It's going to store the name, and it's going to also store the date that the change was made. Create table, and we're going to call this distributor audit, like that. And what it's going to have inside of it is an ID, which is going to be serial primary key, and it's going to have the distributor ID, which is going to be an integer, of course. This is going to also be not null. We're going to have a name, which is going to be a variable number of characters, which is going to be 100, and not null. And we are going to have an edit date, and we're going to make this a timestamp, and it'll be not null also. And that doesn't matter if that's capitalized. Let's throw this here, and we create, don't put the semicolon there, it goes down here. All right, so we got all of that all set up, and that is correct. No, actually, no. Let's get rid of this, put that up there. There we are. Okay, so I got that, and run it. And we created our distributor audit table, which is going to monitor those changes. All right, so what we want to do now is we want to create our trigger function. So remember, this is create or replace function. And I'm going to call this function log distributor name change. And I am going to, what's it going to do? Return trigger. Language, pgSQL, and we'll have this be as, and body, all the stuff that you're well used to at this point, body, and then inside of here we'll have begin, and then inside of there we will also have an end statement. And I'm also going to probably, I'll show you some trigger information variables just to throw some extra stuff into this. Okay, so I'm going to go begin. And what I want to do here is I want to check if a name change has occurred. So how I can do that is I can say if new dot name is not equal to the old dot name, then I want to insert that information. So I'll say insert into distributor audit. This is where we're going to save all of our distributor name changes. And inside of here, I will go distributor ID is going to be passed inside, and the name, and edit the edit date that has occurred. And then I will throw in values, and the values are going to be the old ID and the old name and the current time when this occurred, which will be provided with now. Now, anytime we have an if block, what do? We have to say end if, like that. And everything else there looks good. And then after this, what I'd like to do is also just show you some trigger information variables, just so you see what they look like. So, and this is going to show up in messages. So I'm going to say raise notice. And if you want the trigger name to show up, just like this, and we can go and get it by just going tg name and copy that. And we're going to do basically the same thing for all of the rest of them. If you want to get the table name that we're working with here, we can just go table name, and this will be tg and table underscore name, and paste this. We could do operation, so operation, and this is going to be tg op, and throw in another one. I'm covering most of them. Most of them you won't even care about. So when executed, we can go tg and when. And what else? We could do row, or whether it was a row or statement. So we'll go row or statement. And let's go like this. There that is. And to get that, you say level. And let's say we want the table schema, and this is it. This is the last one I'm going to do. You'll see what they look like. So schema, and that is table schema. SCHEMA. All right, so we got all those different things. And then what we can just simply do at the end here is just say return new. And there we go. And we have our body section. Okay, so we have that set up. So here is our trigger function. Let's say, does it execute? Oh, got a problem here. And actually, this is not the error. I should have put returns. Okay, let's select this again. Come down here and run it. And we created our function. All right, so now what we want to do is bind the function to a trigger. So to do that, you say create trigger. And I'm going to have this be tr so that I know this is a trigger. And I'll say name changed. So if the name's changed, we will have a log of it. And then what we're going to do is I'm going to call the function before the name is updated. Because if I don't do that, I can't get the old name. So this is where before and after come into play. Okay. So before the name is updated, down below, we're going to go through all this stuff. So I'll say before update and on distributor. And we want to run this on every row where an update occurs. So to do that, we say for each row and execute procedure. And then we call our function we have up here. So this is going to be the function name changed, this guy right here. So let's come up here and run that and put a semicolon at the end. Then we'll go and allow for all of our changes to be made. So I'm going to say update is distributor. I mean, this is separate. I should put this on a separate line. So this has nothing to do with this part that binds the function to the trigger. This is something we're going to actually go in and update the distributor name, and then we will see how the new function is going to be updated so that it has that information. So I'm going to say update distributor, and I'm going to set the name to be equal to, and I'll say their new name is Western Clothing. I don't know, I'm just throwing something in there, where ID is equal to 2. And we can come in. Did I run this create trigger? I don't think I did. So let's go F5. Nope, create trigger, there it is. And then let's update it, and then let's test to see if it worked. And you can see here are all of the pieces of information that I asked for down here are showing up inside of the message area. So now that I have that set up, I can go in and check my log. So I'll say select and from distributor audit. Is it in there? And select this and F5. And we can bring this up and you can see that yes, indeed, this is the old name that we had and this is when it was updated. You could also put another field in here that would be the new name or whatever, just by using new instead of old, and that would work also. Another thing I'd like to talk about is conditional triggers. You can actually revoke delete on tables for some users just through the use of triggers. So let's say that we want to set up our system in a way that is not going to allow people to update the records on a weekend. That's something that sort of sounds like something that might be useful. So what I'm going to do is I'm going to say that I want to block weekend changes to our database. So maybe we have people we don't trust on the weekend working and we don't want them changing our database. So we'll say weekend changes like that. Returns trigger, same. Language is going to be the same as body, begin also the same. This is going to be much more simple though. So let's come down here and let's go and delete all that. And inside of here, we're just going to say raise notice and we'll say no database changes allowed on the weekend, like that. Throw that right there. And then you have to return null, like that. And that's it. That's all we need to do for this. Now we need to bind a function to this trigger. So again, this is going to be create trigger, and we'll go and give it a more descriptive name that makes sense. And this is going to be block weekend, underscore changes. And then we can call our function before the name is updated. So we'll say before update, and we will say that we also want to block inserts, deletes, and truncates. How you do that is say before update or insert or delete. See, we can block all of them. Or truncate. On distributor, and we want to run this on the statement level for each statement. And then we will go and do a block here. So we'll say for each statement, when, here is our condition, and we're going to say a weekend. So it'll be extract, and we want to get our day of the week, which is going to be a number, day of the week, like this, from, and we want to get our current time, so we'll go current time stamp, and, time stamp, not stomp, time, or there we are, there, time stamp for current time stamp, like that, and then we'll say between, and 6 and 7 are the weekend dates inside of here. So we got that all set up, and then we'll say execute procedure, and that is this guy up here, and what it simply is going to do is just print out that information. Okay, and we can just go and call it, paste that inside of there exactly like that. And let's go and get this guy and run it. I don't think we did. Oops, syntax error. What's wrong with this? I see. I actually forgot to put a semicolon here. Okay, and let's select it again. Run it. Function created. Good stuff. And let's say equal to my current day, so that this will actually give me an error. So this is currently Tuesday. I'm going to make this 3. Is that right? I think. Well, let's just run it. I think that's right. 2, 3. No, this will be 2. Yeah, so this will be a 2 instead. So let's go and run all of that instead. There it is, and I created the trigger. And now that I created the trigger, I can go and try to make this change again, and it should block it. And it does. No database changes allowed on the weekend. All right. And another thing that you probably want to be able to do is to delete triggers. And how you can do that is very simple. You just say drop event trigger, and then it will be the name we have here for our trigger, which was tr block weekend changes. That guy. And we can take this and we can drop it. All right, so there are triggers, and what I want to talk about next are cursors. And basically, cursors are used to step backwards or forwards through rows of data, and they could be pointed at a row and then select, update, or delete. And cursors get data and they push it to another language for processing operations that add, edit, or delete. And cursors are first declared defining the selection options to be used, and then it's going to be opened so that it retrieves the data, and then the individual rows can be fetched after that. And then after use, you want to close a cursor so you can free up, memory and such. Now, to explain cursors, what I'm going to do is I'm actually going to go and just create an example. I'm going to do a do block here because this is going to keep it nice and simple. And I'll go body like this. And I'm going to say that I want to declare, and I want to declare a couple different variables inside of here. I'm going to have a message and text, and I'll have its default be equal to nothing. And then I'm going to have a record of a customer. So I'll say customer like this, record. And I'm going to declare a cursor. So I'll go cursor and customers and cursor like that. And then I'm going to say that I want to assign this to for select everything from customer. And then we can go in and actually define our code, what we're going to be doing here. Now, if you want to work with a cursor, you need to open the cursor. So we'll say open cursor customer. And then we're going to loop, and we're going to fetch records from the cursor. So we'll say loop and fetch cursor customers into our record for our customer. Let's go and get rid of this and move this down here. There we go. And put a semicolon inside of there. And then we're going to say exit when there are no more customers found. That's what that is actually saying. Then after we do this, what I want to do is concatenate all our customer names together. So I'm going to say message, assign this to whatever our message is, and I'll use these pipes here, and I'll go and get our individual customer first name and pipe this together. And then I'm going to go and throw a space between the first and the last name, do another pipe, and this is just going to output all of our customer names. So again, customer dot last name, and then let's say we want to put commas around all of them. There we are, like that. Okay, and anytime we have a loop, what do we need? We need to do an end loop, like that. And then I am going to output all of this information. So I'll say, let's just put it here. We'll say raise notice, and this will just be a list of customers. So I'll say customers like this, and let's go and throw those in there. And then I can just get them because I have them saved inside of a message. Let's call end, and then let's close everything off altogether. All right, so we got all of that set up. And if we come in and we run it, boom, current cursor customer. I got cursor customer right here, cursor customers. I wrote customers there. So let's go and change that to that. Run it again. And there you can see we were able to jump in there and grab all of our customer names and output them. Now I'm going to do one more example. This is the end of the tutorial. Been a long way, but I think it's very important to understand the concept of using cursors with functions. And basically what I want to do is create a function that's going to return a list of all customers in a provided state. So let's just get rid of all of this and just write everything from the beginning. So I'm going to do create or replace function and function underscore, and we'll say get customer by state. And we'll just do C underscore state for customer state, variable number of characters. And what's this going to return? Well, it is going to return text. And the language that I am using, PLP, GSQL, as, and throw in my body tags inside of here, and another set of them right there. And then I'm going to declare a couple variables. So I'll have declare, and I'll have this be customer names, and this will be text. And to start off, it will have no value. So there that is. And I'm going to be cycling through customers again. So I'm going to go and need a record of each of the customers. I am going to then define my cursor and the query it is attached to. So customer by state cursor. And cursor state is going to be passed inside of here for this query. And I'm going to say for, and let's go down, select like this, and I'll go first name, last name, and state. And I'm going to be pulling this from the customer table, and I will get if it has a match to whatever the state was that was passed inside of it. Okay, so I got all that set up. Okay, now I can come in here and start writing everything else. We'll go begin, and we'll go end like that. And let's move this down here so we can fit more code inside of it. Now, of course, I need to open my cursor. So to open it, I just get open, cursor, customer, by state. Why don't I just copy this so I don't have any typos inside of it? Oops. Cursor customer by state. Cursor customer by state. There it is. And I need to pass in C state. And then there that is. After I have that all set up, I'm going to create a loop. And we do an end loop, of course, like that. And then inside of here, what I want to do is I want to move my row of data into the record that I have right here. So to do that, I'm going to use a fetch cursor customer. Oops, I have that still saved, don't I? Yeah, I do. And we'll put that into our record for our customer. And then I'm going to continue looping until nothing more is found. So I'll say exit when not found. And then after I do all of that, I want to concat the customer names for each of the rows. So I'll say customer names and assign to that customer names, and we'll do a pipe. Go and get our record of our current customer we're working with that we're looping through, and get the first name for it. And we'll put a pipe here and a space and another one there. And then we'll go and get that customer record again and get the last name. And then we have to put another pipe, and then we'll have everything separated with commas, just like we did before. And then this ends our loop, And of course, after we end our loop, we have to close our cursor. So we'll say close and cursor customer by name. Do I still have it in there? Yes, I do. So let's paste that inside of there. And then after we do all that, we can say return, and it'll be all of our customer names based off of the state that we said we wanted. This ends, the body ends, and then let's say we wanted to get all of our customers from the state of California. We'll go select, and let's come up here and get this function right here. So let's grab that, copy, jump down here, paste that inside of there, and then we'll paste in California. And there that is. And of course, we have to select all of this, all of it, and run it. Did we have any errors? No, we did not. And then let's go and run it, and we'll get a list of customers from California. And there we are, and here they are. So there you go. Okay, so now I want to cover installation. Now installation's largely, it's very, very simplistic. So basically, no matter what your operating system, I'm using Windows here, obviously. So you're going to want to go to the PostgreSQL.org file. You just type in Postgres and download. You're going to see this page right here. Then you're going to want to pick the latest version of Postgres. And you're going to be sent to a page like this. Again, you're going to want to pick whatever of the operating systems that you are currently using. I'm clearly using Windows. And then this is going to open up, and you just basically next your way through the whole thing. So just next, and you can define where you want it to be set up and click on next. And then you're again going to select, just make sure you do not select Stack Builder in this situation. So everything else should be checked, and click next. And then you can go and select the directory you want to store your data in, again, next. And then you're going to define a password that you're going to be using. So go into, that's basically an administration, so click on next after you enter that in. Then you're going to want to set your port, which is going to be 5432, and click on next. And then I just leave this as default location, default locale, that is. And then basically everything's just going to install for you. And there you go, you have basically everything set up. Now click on next. And then after everything has been installed, you're going to see a message that looks like this. Then what you're going to want to do is you want to find pgadmin. It's currently version 4, and you're going to want to open that up. And right here, you're going to set your master password. So just type in whatever your password is and click on OK. And then you're going to enter a password for your user. So just come in here, click on OK, and you can enter it again and click on OK. And then you're going to see pgadmin pop up just like this, just like we worked with in the tutorial. So there you go, guys. That is basically a vast majority of anything you're going to do with Postgres outside of some administration and such. I mainly focused in on the programming aspects, which I believe are what most people come to my tutorials or my channel for. And like always, please leave your questions and comments down below. Otherwise, till next time.